Hey guys, good morning. Um, I suppose you're all familiar with Zoom's interface. If not, I'll just give you a small primer. There's a chat window that you can ping on in case you have any questions at any point. And how this will go is this is a bit different from. Hey guys, good morning. Um, I suppose you're all familiar with Zoom's interface. If not, I'll just give you a small primer. Uh, yeah. Okay. What do I say?
This will go a bit different.
Yeah, correct. Yeah, because I got distracted by the echo I got from YouTube, which is a good segue into saying that this is being streamed on YouTube. So even later, if you want these talks for reference, we'll be able to do it. We'll be able to see it, right? Which is a bit of a change from the physical meetups because we've always been crippled by the fact that we don't have proper recording facilities, right? So, but the last two meetups are available on YouTube. Not last two, just last one. The Flask workshop is available on YouTube. So will these four talks that we have today. Okay. Um, so what else did I have to say?
Just a little bit about Bangpypers.
Yeah, I mean, see, Bangpypers, I don't think anyone here is new to it, but about Bangpypers, we've been conducting meetups and workshops and talks for the past 15 years, but it's not just been the three of us. It's been started by a lot more people, and it's been conducted by volunteers across Bangalore for the past 15 years. And now it's me, Anirudh, and Ritesh who are primarily running these workshops and talks. So if you have any talks that you want to present in the future, you can reach out to us. And if you are interested in volunteering, we are always looking for volunteers, right? So yeah, and about the difference that I wanted to say about Zoom versus physical meetups, right? It is new to us as well in terms of how to interact with people and all of that, because we can gauge participation and interest and whether the topic is boring or if people are actually interested. We can see it live in a physical meetup. We can see people's reactions. Here we can't. But the other part of it is that even if people are fatigued by meetups, they have the luxury of just turning off for around 1 to 2 minutes and coming back, which is the other side of it, I suppose. And we're just rolling with it. We'll see how we can make this as interesting as possible, even in an online interface like this. I think the Flask workshop last time by Vinay was amazing. I don't know how many of you are there, but we had a lot of fun. It was around 6 hours, and we didn't know how fast the time flew. Anyway, we have four good talks that we've lined up today, and I think at least three of the speakers are here. Let me just bring the lineup, the schedule up. Okay, so the first talk we had planned was by Hiral Amodia, and it's about the time complexity of algorithms with Python examples. And the second one planned is unit testing in Python by Rohit Sanjay. And so normally when we have breaks, we tell people that you can interact and stuff. I don't see how we can manage that as smoothly as in a physical meetup. But what we can do is, allow for the space to be active, as in the meeting will be going on, And if anyone wants to talk about anything that they want to talk about in the future, if they have any interesting observation in Python or anything that you want to share with the group, you can. If you want to just ping on the chat, you can. And yeah, and after that we have two more talks, which one of them is Pythonic interfaces by Praveen. I see he's already here. And the last talk is about code quality, the practice and tools by me, Abhiram. So that is the lineup we have for today. And somewhat serendipitously and a bit of planning, it's been theme of testing and quality, code quality, which I think is something that we don't actively keep in mind, but it's very vital for our projects to go, smoothly and without bugs in production. So I think that is something that we're going to be seeing today. Yeah, I think if Anirudh and Ritesh don't have anything else to start off with, I think Hiral, stage is yours, so to speak.
Cool. Hi, good morning all.
Just one more thing. Sorry, Hiral, one more thing.
No problem.
All of you are muted at this point, but I request that all of you remain muted during the session. At the end of the talk, you can either ping your questions on the chat window, or you can, there's a small raise hand. No, is there a raise hand button?
Yeah, it is there.
Okay, yeah. So you can just click on the raise hand, and you can unmute yourself. So we'll have a bit of an order, right? So yeah, Hiral, back to you.
Thanks, Abhiram. Hi all, good morning. So first of all, thanks to Abhiram, Anirudh, and Ritesh for moving this meetups to virtual. At least once in a month we get to talk, interact with each other, and know what everybody is doing in this amazing world of Python. So thanks for that. And Abhiram, you rightly mentioned about the differences between the physical versus virtual meetup, where only one point that you missed is the samosas. We don't get samosas here from you now.
Yeah. We'll see if we can have something with Dunzo, but I think it's a long shot.
Okay. Anyway, so I'll share my screen. I want to talk about time complexity in algorithm. You have disabled participant screen sharing. Is it possible to enable it?
Yes, one second. Sorry.
Yeah. So by the time he allows me to share my screen, so today I want to talk about time complexity of algorithms, and how it struck me to explore this is when I used to take interviews for my organization. So I work in Happiest Minds Technologies in the capacity of an engineering manager, where my work is a techno-functional, where I basically still I am hands-on with coding and reviews of my team members, and that is how when I interview people for my team, I always found that the code that they write was a lot of times inefficient. It lacked a basic understanding where something can be achieved in multiple ways. So that is when I also started exploring. I came across this time complexities of the algorithms, and I explored it. I got some basic understanding, and then I thought I'll write about it. And today I got an opportunity to present it here. I know all of us are working, and all of us are hands-on and expert in Python. So this, whatever I'm presenting, might not be new to many of you. So if you feel that there is anything further that I can learn, or anything further that I can improve on my understanding of time complexity, then please feel free to teach me further on this. So with this, I'm sharing my screen. Yeah. So this is a blog post that I have written on my on my LinkedIn account, in my LinkedIn profile. So I thought I will continue with that rather than making any slide deck, because it would have been just a copy of that. Cool. So time complexity. We all, as a software engineers, we have evolved from writing code from understanding of algorithms. Many times when we still do designing, we write algorithms first and then convert it into code. So efficient algorithms basically gets converted into efficient code that we all know. And in order to write efficient algorithm, there are a couple of things that we can take care of, out of which one is called the time efficiency of an algorithm. Now, with all this in mind, I just wrote this blog post. So when we say efficiency of a code or algorithm, it usually gets measured in three aspects. One is how fast or quick it executes. That is what we say efficient code. How much memory it takes while executing. So how many variables are used, or what different kind of basically data structure are used. How basically is the memory released back after use. This is all the aspect that comes under the how much memory that it uses for execution. And third is how much readable or understandable a code is. So in this particular segment, we will touch base on something called time complexity of an algorithm, which is also called asymptomatic complexity and is described by a mathematical term called big O notation. I have used Python-based examples here, but that does not mean that it is only specific to Python. The same thing applies to all the other programming languages because it actually applies at algorithm level. There are many references like this that you will find on internet, like the one which I have written, and those have been a source of inspiration for me. And I have taken some time to share all the links below from which I have learned. And here on, I will be mentioning everything in terms of code because I will be using certain code snippets to explain or demonstrate the time complexity. But it means that this can be implemented at algorithm level as well. Guys, in order to basically have efficient time, I am going with the flow. But if you feel that I'm going fast, then please feel free to bug me. Okay. Let us touch base quickly upon what it is not first, because the term itself is little bit confusing. When it says time complexity, when I ask a lot of candidates about time complexity, the first answer that I get from them is that the number of time that it takes to execute a piece of code. But that is actually only partially true. It is not about the time taken. You cannot basically measure time complexity with a stopwatch approach where you will execute a code and then you will measure that this takes so much minutes or seconds of the execution, because it varies from CPU to CPU, as there are a lot of environmental parameters that impact the actual time that it takes for a piece of code to execute. Even on the same CPU that you execute, and if you put your time measurements, you will get different time measurements for the same piece of code that you execute n number of times on the same CPU. So when we say time complexity, it actually does not mean the actual time taken for execution of the code. But what it means is that somebody has pinged.
Cyril, you can continue.
Sure. Yeah. So what it is? Okay. So what it is that it tells that how many primary preliminary operations are there in the code, and assuming that the preliminary operations will take same amount of time that you execute n number of times, it explains that how the code will perform when you move from best case scenario to worst case scenario of your input. So as the input increases, as the input goes larger and larger, how will your code perform? Whether the code will still perform the same, are there the same number of preliminary operations that it is going to execute, or the time increases. That means the number of preliminary operations that it needs to execute keeps on increasing, and hence you can expect that with certain size of the input, your code will further actually degrade in terms of performance. So there is a very nice wiki definition that is also given by Wikipedia about time complexity, where it says that in computer science, the time complexity is the computational complexities that describes the amount of time it takes to run an algorithm. The complexity is commonly estimated by counting the number of elementary operations performed by algorithms, supposing that each elementary operation takes a fixed amount of time to perform. Thus, the amount of time taken and the number of elementary operations performed by algorithm are taken to differ by at most a constant factor. Yeah, so that is what I just explained, that what it says is in your algorithm or in your code, how many preliminary operations are there, how many basic operations are there, and with your increase in input, whether your algorithm will still hold the same performance or it has to execute those basic operations multiple times, and hence indicates that your code will actually degrade with an increase in the input size. There are a lot of there is a lot of research and a lot of work done around this. Okay, one thing I forgot is yeah. So it is mentioned in terms of a mathematical notation called big O notation. That is how it is. It is called out. So when you say O of 1, it is like O of 1, O of n, O of n square, etc. There's a lot of time complexity research that is done, and a lot of different time complexity algorithms have been put out. Here in this particular section, I will touch upon certain which are very common, which we encounter mostly on a regular basis whenever we write or review certain code. So I'm going to touch base upon 7 time complexity patterns here, which I have just noted down here. Okay, so we'll just take a pause here on this graph for a few minutes. This graph is again available in Wikipedia, and this graph actually shows how a particular time complexity algorithm will behave when the size of the input increases. So the best case scenario, as you see on the purple in the purple color, is time complexity of 1. So that means that irrespective of the size of the code, there won't be any performance degradation in a particular logic, that it will always remain constant. And as you can see here, O of n, that is the green line, that is like the standard median. So it says that your code will degrade in a linear fashion. So higher the bigger the or larger the input size, the larger the degradation will be. Smaller the input size, the smaller degradation. Everything below green line is efficient than the linear complexity. Everything above green line is going to cause more degradation. So as you can see, certain here O of log of n, if you see in the blue, it is closest to O of 1. So if you can write your code, or if you can modify your code into O of log of n, that means that with increase in input, your code will degrade least. The reason I'm showing this graph is that because we all know that a certain piece of logic we can write in multiple ways. So at some point of time, if you feel that your code is in O of n square or O of n log n2, then you should try to bring it below this green line. At least you should try to bring close to the green line, where you will have a predictability that my code is going to behave degrade linearly. I'm not going to get any surprise where suddenly I get a big input and it degrades exponentially, like the ones which we see on the left side of the green bar. And any code that you can modify and make it efficient to bring it under green line, it will keep on increasing the efficiency of your code as the input degrades. Any questions or anything that anybody wants to share so far before we move on to the examples? Cool. So as I said, I want to touch base on 7 most common time complexity algorithms or time complexity logics that we come across when we write our code or when we review a code. Usually we don't even know, but inadvertently most of the logic falls in one of these 7 categories. So first is constant time. That is the purple line here, O of 1. So a constant time is a complexity where, irrespective of the size of your input, there is not going to be any degradation in the behavior or in the working of your code or the algorithm. So as you can see in this example below, I am reading the first and last element of an array, and I am reading it using the direct array indexes. So when I read using direct array indexes, I don't traverse on the array, and I just use inbuilt Python functions to read the first and the last array index. So it just pulls the elements from the memory and prints here. So in this case, irrespective of the size of the array, whether it's an array of element 0 or 4 elements or 100 or 1000, 10,000 elements, my performance of this particular code is going to remain constant because I'm not traversing on the loop. I'll just wait for a few seconds on every piece of code. If anybody has any suggestions, then please feel free to guide me or help me to improve further on whatever I have done. Next is linear time. So this is the green line, which indicates that there is a predictability. So the linear time complexity is something where you always have a predictability that with increase in the size of the input, your code will degrade in a predictable fashion. It will degrade with in a linear fashion. So as we can see this example here, what I'm trying to do is that I'm trying to sum all the elements of an array by traversing into it. So I have written a for loop where I get the array, I traverse on each element of the array, and I basically sum it. So here, as my input increases, my code has to basically execute my loop execution will also increase those many amount of time. So this is a linear fashion where I know that with every increase in the size of the code or the input, my time degradation will be linear. Next is quadratic time, that is represented as O of n square. So O of n square is here. The brown color just right to the n factorial. Here, as you see, the degradation is exponential. So when my input size is close to 10, it is basically very close to the axis. And as the input size increases, rather than degrading it in a linear fashion, it degrades exponentially, and the time increases drastically. So as an example, here, what I have done is I have taken a two-dimensional array. So an algorithm or a code where each input has another O of n complexity of the code. So O of n complexity we already saw in the example above. Here we have another loop. So it is like I am traversing on my input twice. So for every input, I am traversing on the whole set of input once. So that is the reason why it becomes squared up. So here I have taken an example of a two-dimensional array or a multi-dimensional array to put it like that. So and I am doing an addition of all the elements of a multi-dimensional array. So for every input that I have, I traverse on those many times on the sub inputs, and that is how my time complexity increases exponentially in a squared fashion. Sorry, not exponential, but in a squared fashion. Okay, so next is the exponential O of 2 raised to n. Yeah. So this is, sorry, by mistake, I just explained this 2 raised to n, but 2 raised to n and n square, they are close. As you can see, they are just close to each other in terms of the performance. So exponential time complexity is where with every increase in size of the input, the time increases on exponential way. So it is always, it degrades in 2 raised to n order. So I'll just explain it with an example here. So in the code below, I am calling a Fibonacci function recursively to calculate the sum of Fibonacci numbers up to its input parameters. So I'm giving an input and I am calculating the number, basically recursively, I'm calculating the sum of the Fibonacci series up to that number. So here, as you can see in this table, for the size of input 1, the number of recursive calls will be 1. That is, when we put it in 2 raised to n expression, it is 2 raised to 0. When I increase the size of input to 3, it will have to make 5 recursive calls to make the sum. when I increase the size of input to 5, it will need to make 15 recursive calls. So if you see the 2 raised to n expression, then when my input size was 1, it was 2 raised to 0. But when my input size was 5, it increased to 2 raised to 4. So this table shows that how this will degrade. So from input size of 1, where it was 2 raised to 0 times execution, it will basically increase to 2 raised to 6 times execution when my input size becomes just 8. Okay, so this is how basically drastically your performance will degrade with every increase in the size of the input. Next is a logarithmic complexity, that is O of log n. That is what we saw here in the blue line. That is considered to be one of the very good ways of writing a code, because the time complexity is even lesser than the linear time complexity. And what happens in a logarithmic time complexity is that the size of the input that you traverse keeps on reducing with every iteration. So binary search is an ideal example of logarithmic time complexity. So in binary search, what we do is that we keep on traversing on the half of the input than the previous iteration. So as you can see here, I am just trying to find an element 2 in this array, in this list of 8 elements. And with every iteration, the input keeps on becoming half. So in the first iteration, I basically have my input range from 1 to 8. In the next iteration, it becomes half. It becomes 1 to 4. And in the third iteration, it basically reduces to further half. And in the third iteration itself, I find my search element. So a binary tree is an example where you reduce your complexity of every iteration by half of the previous search that you did. So if you can write this kind of code, or if you can modify your existing code in such a way that you can keep on reducing your input sizes every iteration, then your algorithm or your code will keep on becoming more efficient. Next is a quasi-linear time. So it is O of n log n. So we already saw n log of n here.
Hiral, we have a
Yeah.
question here.
Sure.
Square root of n. Do you have an example for this?
No, I have not taken example of that, because usually we or it is not a very common algorithm. It is not a very common pattern. So I took a log of n and I have not taken square root of n.
I see. Okay.
Yeah. Okay. So in case of n log n, you have a binary, you have an underlying binary search, or you have an underlying log of n algorithm, but your input needs to travel n times on that complexity. So here we have an array, list of list, and for every element of that list, we are traversing on the binary search function, causing log of n complexity further. So this is an example of n log n time complexity. Okay, next is a factorial time. As we can see in this graph, among all the common time complexities, factorial time is the most expensive when it comes to the degradation of the algorithm or of the code. So in an algorithm or code where the operation execution complexity increases factorially with the increase in the input size is called a factorial time complexity. So I have just taken a simple example here that how it degrades with every increase. So from 5 to 10 to 15, as you can see, it basically degrades in a factorial fashion. This is a very basic example of factorial time complexity, because to be honest, it does not depict much about how it degrades. And in order to understand it, we need to understand a lot more, and that's the reason why I have put some links here if anybody wants to go through in detail of the factorial time complexity. Okay, so we'll take a pause here, and I think I went little bit fast in order to save the time and leave some time for any discussion. So if anybody wants to discuss anything, or if we want to revisit any of the algorithms that I have shown here, we can do that.
So, Hiral, one of the questions here is timing of the operations, and I actually agree. What we are missing here is the proof of the pudding in terms of like what is taking lesser time. So, do you have any metrics for those?
See, as I said, right, time complexity is not about time. Time complexity is only about how many times your code has to repeat your primary preliminary execution. I have put the metrics for logarithmic, as I have shown here, that for logarithmic, how your input keeps on becoming half. And there is a metric here that I have put for exponential time, indicating that with every increase in the size of the input, actually how it will degrade exponentially. So these are the two metrics that I have.
No, agreed. But thing is, this is theoretical. Okay, this is theoretical. The practical part of this is how does the computer exhibit it, right? It is by time only. Like there is no other way of time and space, of course. But as far as the number of iteration goes, that translates into time. So I think that's what Ashish is asking. I agree with your point that the iterations are a good indicator, but that is what it is. It's an indicator. It is not.
No, Abhiram. What I'm trying to say is that iterations are the only indicator. I'm not saying iterations are the good indicator. Time complexity does not have anything to do with time. Time complexity has to do with how many preliminary operations that your code will have to repeat with increase in the input size. And you can assume, if you want to take an assumption, you can assume 1 second for every preliminary operation. And then the number of iteration that it has to do, you multiply with 1, then those many seconds it will take. Okay, so in time complexity, whatever is your number of repetitions, you can just assume some time, and for any time that you assume, you will always see the same degradation. So time is not an important factor of measuring time complexity. Okay, it is termed as time complexity because it ultimately translates that if your CPU takes X amount of millisecond to perform one preliminary operation, this time complexity gives you an indication that how will it degrade.
Right. Okay. It is still an assumption that it will take 1 second, which is not the case. So, okay. From my experience, there is this tool called Line Profiler. Okay. And that is actually a good complement to this, right? As a supplement or supplement. I think I'm using the word wrong. It's an addition to whatever you have presented. And Ashish, you'll get an answer for this when I get to my part of the presentation where I'll be showing a small demo of this. So it'll complete the whole picture, I suppose. So yeah.
Sure. That will be interesting for me also to know. Thanks, Abhiram.
Sure. I think Bikash has one question. So maybe there can be an algorithm O of n square, which is faster than O of n because the first algo takes lesser time. No. So again, see, this totally depends on the value of n. Okay, so that I mean, like n versus n square, there is no debate that n square is slower, but at least for n greater than 1. But there are some values, like if you say n and log n, then at least to some value of n, you can say that you'll get comparable speeds.
True.
Okay, so because is that the answer to the question, or did you have like totally different interpretation?
See, for the same input size, okay, for the same algorithm, O of n square will degrade more compared to O of n. But yes, you can have two separate functions. You can have two separate piece of code where you will be able to see O of n square performing better than O of n, because it all depends on what are you doing inside the code. What I'm trying to say is that for a certain logic, you can improve your code. If it is in O of n square, you can actually improve it by bringing it to O of n. But for two separate logic. Okay, one piece of code is doing X functionality, another piece of code is doing Y functionality. Then when you compare these two, then it is possible that O of n square of something is better than O of n of another thing.
Guys, we are on time, so maybe we can start backing up.
Ani, I think there is one more question from Sai, if we can take this up.
Sure. For the factorial function, suppose the input is integer 10 within the function. Suppose I convert the 10 to range 10 and line 2 onwards, I multiply all the numbers in that range. Become linear from the line. No, actually, so if you are see here in the factorial function, what it is doing is it is calling recursively. So if your function is still under the recursive call, then actually if you are doing this inside that, then actually you are increasing the complexity. So if you want to break the factorial complexity, then you have to break the factorial itself. You have to break it in such a way that you don't call it recursively in a factorial fashion. Yes, O of you are correct. Range function of X, but that is the reason why I have used range function only in creating the input. If you see here, O of 1, I am only using it in creating the input here. I am not using it in my function. But you are completely right. Range function is something with that also impacts. It is not as good as O of 1.
Okay, cool. So if we have any more questions, I think we'll just have them on the chat, but I think we do have to move on. First of all, Hiral, thank you so much. I mean, this was very cool. I mean, like, I think I'm sure a lot of people did need a revision, even if they knew about whatever we've learned, right? So thank you so much for this. I think it's very important to keep in mind when we code. And we will revisit it in case someone else has questions. But for now, I think Rohit, you're up next, so you can share your screen.
Once again, thanks to Bangpypers. Thanks to all of you for giving this opportunity. And thanks to all the participants for interesting questions. There are a few things which I have noted. Again, as I said, we all are in a learning phase. So definitely a good learning and a lot of takeaway for me also from this. And sorry if I went a little fast. I'm not very much used to webinars, giving webinars. So if there was any deficiency in my presentation, then I apologize for it.
I don't know about the others, but I think it was very clear. And in terms of pacing, I wouldn't worry about it because it's a learning thing for all of us. So I think it was fine. And if it was a bit fast, also the fact that all these resources are still available for retrospective viewing, I think it'll fill up any gaps that we have in terms of catching up.
Sure. Thank you so much. Thanks, guys. I'll just go on mute.
Rohit?
Yeah, hi.
Yes.
Okay. Okay, hi everyone. My name is Rohit, and I'll be talking about unit testing in Python. So a little bit about me. I am a final year engineering student, and I have previously interned at a startup called JovianML, where I worked on setting up the entire test suite for their Python library. And that's how I am able to talk about this. I'm able to talk about unit testing today. And I'm also a GSOC intern this year at an organization called NumFocus. And I'm working on a project called Testbook, which is a unit testing library for Jupyter Notebooks. You can find my blog at rohitsanjay.com, and you can find me on Twitter at I'm Rohit Sanj. So the agenda for today is I'll just be talking about introduction to unit testing for a very short time, and I'll mainly cover the chunk of the talk is writing unit tests, like how you can write efficient unit tests. And I'll talk about mocking, I'll talk about using context managers to spice up your tests, and I'll also talk about pytest, some of the pytest features that are really useful in writing efficient and maintainable tests. So I'd just like to start with this quote. I just want to stop here and ask if you can see my screen. Can someone give me a?
Yes.
Okay, thanks. So more than the act of testing, the act of designing tests is one of the best bug preventers known. So I want to explain this. I mean, it's self-explanatory. So, all right, introduction to unit testing. So unit testing in 2 sentences, it's a unit test is a test that checks that a single component operates in the right way. So, and also a unit test helps you to isolate what is broken in your application and fix it faster. So the key word here is isolation, that it helps you just need to isolate the component that you're testing and try to abstract away any of the other interactions that it may have with other components. So because you're only testing that particular component. And so this is how a simple unit test might look. So I mean, this is not a unit test, but this is just some function called add in a module called foo. And let's say I want to test that add function. So I'll write a test underscore foo.py, which is that's the convention. Like if there's a module source code module name foo, you write test underscore that name. So test underscore foo.py, and I import my function under test, and I write some assert statements. I say assert add 1 2 should be 3, and hello and world should be hello world. And to run the test, I just I'm using a library called pytest, which is a very well-known testing framework for Python. So I just say pytest verbose test foo.py, and you can see that it says, okay, I collected 1 item and I've and the test has passed. Right. So this is basically how unit testing looks in Python. All right, so let's get into writing unit tests. So there's 2 main libraries that are available in the Python landscape. I mean, there are more, but this is the most common. Unit test being the one that ships with the Python standard library. Unit test is the default unit testing library that comes, as I said, with the Python standard library. And pytest is a third-party Python package that you can download off of PyPy by doing pip install pytest. And usually the norm is that pytest wins in most cases. I mean, pytest is usually preferred. And I'm going to talk about why, because first of all, unit test, there's too much boilerplate code needed to set up a simple test. Okay, and the API can make the test code's intent hard to understand. So what this means is that there's too much abstraction. So you have a lot of self.assert equals, self.assert not equal, self.assert greater than, less than, more than, I mean, a dict equal, list equal. There's like a bunch of it. So and you might not remember the actual order of arguments. You have to look it up in the docs. So there's a lot of API that you need to look up and remember. Whereas with pytest, you can just use plain assert statements. And there's also camel case naming in unit test, which is actually derived from the JUnit style or the Java style of testing, unit testing, and hence it was that's where it's inspired from. So, and also idiomatic Python uses snake case, so it can be a little weird to see camel case and snake case in the same document. And talking about pytest, you get detailed info on assert statements. So if you see when some assertion fails, you just get an assertion error. But with pytest, you can actually see the diffs in the values where and exactly pinpoint what was the change in the expected and the actual value. And there's also auto discovery of test modules, which also exists in unit test, but in pytest it's a little more sophisticated because it even searches the test underscore functions and classes and stuff. Test star, I mean. All right. And there's also modular fixtures. Okay, so I'll be talking about fixtures in a while, but fixtures are basically functions that you want to do for setup for any test. And yeah, so modular fixtures for managing small or parameterized resources, and also test parameterization. So if you saw earlier in the test that I'd written, you saw that there were 2 assert statements, but with test parameterization, you can make that modular and make it just one assert statement, and it's essentially like a decorator on the test, which runs through all the test cases. So I'll be talking about parameterization as well later in this talk. And also you can run unit test suites out of the box. So it's sort of like a superset of unit test. And there's also a rich plugin architecture for pytest with over like 315 external plugins, and the plugin that almost everyone uses is the pytest coverage, which is a coverage library which calculates the code coverage after running the tests. Code coverage is a way to just capture which lines have been executed and which lines have not been, so that when you ship your code to production, you know exactly which lines have been untouched. So if you get a bug from that exact line of code, you know why, because you haven't tested it. Okay, so it just basically tests that all the parts of your code have been covered properly. All right, and also you have to admit that pytest just looks so much better. Like, this is the usual Python unit testing, like the output, and not that great. But this is pytest, right? So there's a lot of colors, a lot of greens, right? That's good. Okay. Next, I'm going to talk about mocking. Mocking is a principle in unit testing that basically you create mock objects that simulate the look and feel of real world objects, because you don't want to actually do those actual API calls or actual database calls. You don't want to actually do them when you're running the test, because you might crash your server or something. So you want to mock away those interactions. Okay, and this is how a simple mock looks. And ironically, it's from MATLAB. This one, anyway. So if you have this, let's say, orange component, and it's interacting with like these other blue components, like in production, then under a test you should actually mock away those blue components, such that you actually give it the actual desired interaction, but it's actually not doing those calls. Okay. All right. So I hope this picture is clear. Okay. So now I'm going to talk about how you can use how you can use mocks in Python. So the mock library is nested under the unit test library in the standard Python library. So, and the first API that we look at is the top level API, which is called the mock class with the capital M. And this is basically how it works. So you just import mock, and you initialize a mock, and then you can do basically whatever you want with this mock. So you can say m.foo equal to 42, m.bar, it won't complain that, hey, I don't know what bar is. It'll just give you another mock. So, and if you call, let's say, m with parentheses, it'll just say that, okay, here's another mock. And if you keep calling that, it'll just keep giving you more and more mocks. Okay. And there's also a patch. So the first is mock, next is patch. So patch, basically, as it says, it patches away a particular object that you specify with a mock, okay, during the test. And patch can act as a function decorator, a class decorator, or a context manager, as we'll see in this slide. And so if you see here, the patch, focus on the code. So if you see here, it says patch module.class name 2, class name 1. So what it does is it actually doesn't transfer the call to those modules. It will actually just return mocks, and then you can do whatever you want with those mocks. Okay, so right. So another example of mocks. Of patch. So if you have like a module foo.py, and you have a class with capital F foo, and you have a bar.py, these are both source codes. Okay, and you, let's say, import this class foo in bar. Okay, and you do some function in bar.py. Okay, so you write a unit test for, like, let's say, some arbitrary function in bar module like this. Okay, so you would say with mock.patch bar.foo as mock foo. And this is very important to understand, because if you see this bar.foo, it doesn't say just foo, it says bar.foo. And that's because it comes from bar.py. And it doesn't come from, it shouldn't be referencing to the foo in foo.py, right? And that's very important, because you should mock an object where it is used and not where it came from. Okay, so let me just quickly say that again, because you should mock. Yeah.
Can you slow down on that point? Because I think it's a nuanced point that needs to be understood.
Sure. So what I was, I came back to this. That's right. So what I was saying was that when you patch a class, when you patch a certain function in a module, and that module is, let's say, using some class called foo. So what you should do is you should patch that foo which exists in the locals of bar module, and not patch the foo that exists where that foo was defined. Okay, and by this I mean the class foo. I should have actually named these files in classes differently, but anyway. So so what I'm trying to say is that this bar.foo, when you write a test for a function in bar module, and that bar module uses that class foo, right? So you should actually patch the foo that exists in the locals of the bar module, right? That's why I did this animation. And you shouldn't actually just write foo, because that will probably pick up the definition in foo.py, or you shouldn't write foo.foo, but I can't help but say that anyway. So I hope that is right. And so that's what this means: a mock-in object where it is used and not where it came from. And please feel free to stop me if you have any questions. And so next we'll come to when to use mocks. So the basic idea is don't use mocks when you don't actually call something. That's it. I mean, there's not much science to it. All right. And so first thing is system calls, right? So this is one of the API, one of the helper functions that we have defined in our Jovian.py library. So it just gets the path that's in the conda.exe, and if it can't find it, it'll just raise an error. And so if you want to write a test for this, in a non-ideal situation, you would have to actually inject the environment variable and then run this function, and then again put the environment variable back. But that's a pretty weird way of doing it, because you're actually messing with your local systems setup. So next time when you run Anaconda, it might fail because you actually messed it up during some test, right? And also if you mess it up and the test fails, it might not reset it back to the original conda.exe, because you might not have put it in a try finally block. So anyway, so system calls are basically any OS calls, anything that has to do with the OS or sys library in Python, you should mock it away. And you can do that with a patch.dict. So it patches the dictionary os.environ to be whatever I want it to be. And it's basically a dummy value that I can give here, right? It can be anything. It can be hello world or something. So, and I can assert that it is that string that I've specified. Okay, so system calls. Next is network or API calls. So if you have, let's say, an API call that is doing some GET request or something, then you can write a test like this. Okay, so you batch requests.get, and you say, actually should have been API.get now that I think of it. Anyway, so you should say patch whatever API.get, and then side effect is mock request get. So I'll talk about this in detail. So I'm just going to put this up in a bigger way, in a bigger size. So if you see the side effect, right? Let's just focus on this for a moment. So, and if you see here, I'm using patch as a decorator. Okay. Anyway, so what is side effect, right? I'm going to talk about a little bit about side effect. Okay. So so when side effect to a mock or a patch is an exception, then when that mock is called, it does that side effect. So side effect is basically, it dictates what should happen when the mock object is called. So when your function is called, should a file be created? Cool. Then make a function that creates a file and pass it in as a side effect to a mock. Okay. So stuff like that. So it dictates what the side effect should be. And when the side effect is a function or any callable, and you assign, so there's a function called side effect here, and it just takes in some string and returns some value. So and then we create a new mock and assign its side effect to that side effect function. And then when we call mock with those whatever values, you get back what the side effect returns. So it just passes along that argument to the side effect and executes it. Okay. And when side effect is an iterable, so if you see here, I've created a new mock called foo. And I assign the foo side effect to be first this, then this, finally this, like 3 strings in a list. And when I each call them, and it returns these arguments in that exact order. Okay, so this is very useful in cases where you're actually mocking some function, but it actually executes 3-4 times in the same test. So you would want to actually provide different values for each function call. So that's when you use it. Okay, and this is just from the docs that I picked up. If side effect is an iteral, then each call to the mock will return the next value from that. Okay, let's get back to when we should use mocks. So as I said, system calls, network API calls, DB calls, IO operations, and unpredictable results. Okay, or random, because if you use the random library, then you can't test that. You have to mock it away because it's random. Okay. Next is using context managers. So this is not a pytest feature or something. This is a Python core feature or Python core construct. So I'll just talk about context managers in Python just for a brief moment. It's just a protocol, like all protocols exist in Python. It's just a simple protocol that your object needs to follow so that it can be used with the with statement. Okay. And you need to add the dunder enter and dunder exit methods to an object if you want it to function as a context manager. Dunder as in double underscore exit and double underscore enter. Okay. So, and also Python will call these two methods at the appropriate times in the resource management cycle. So here's a quick, and also this is a quick pun. Are you with me? Okay, anyway, that would have worked if I was physically next to you, but okay. So this is the basic example. So I have a class foo, I define some enter method, I define some dunder exit method. And when I say with foo print hello world, it will say entering the context, hello world, exiting out. So this should make it clear exactly what a context manager is. So the folks over at the Python core community realized that this is too verbose and there should be a better way of doing this. So what they did was they created a library called contextlib, which basically you can define a generator which will automatically support the with statement by using a decorator called context manager. So there's three different terms here. So which is you decorate a generator to give a context manager. Okay. So that's exactly what it is. So if you see here, there's a foo function. You say print entering the context, then you yield. Yield is basically you pass on the function, you pass on the execution subroutine to some other thing. And in this case, it's the with block. Okay, so it's a print entering context, yield, print exiting the context. So with foo print hello world, and it's same things before. Okay, and how it works is you add the decorator at context manager. So this is a quick pun again. So with that context managed, we can now move on to the next part. And if you want to know more about how it beautifully intertwines like this, the decorators, generators, and context managers, and also if you want to know more about the Python data model, you can watch this talk by James Powell in PyData Seattle. So you want to be a Python expert. Okay. So finally, we can come to how you can use context managers in unit tests. Okay. So if you see this temp directory, I've defined it as a context manager. And I initially say, okay, I want to get the original path first because I want to be able to go back to my original path when my test is, when this context manager exited. So I say, okay, fine, create a new temporary directory and change directory into that directory and yield it. Okay. So whatever test happens with this temporary directory, right? Like let's say if it creates some file, it deletes a file, it does whatever it wants, it will do it in a temporary directory. So my main system is not corrupted. Okay. And even if this thing throws an exception, I will always finally change my directory back to the original path. Okay. So this is one quick way of using a context manager. So this is used, if you see here, it's actually used in our tests. So if you can find it on GitHub. And this is another place where we use this temporary directory. So and it's in a mock Git repo. So there were some in our API, there was some Git commands that we had to run to do some functions. So we had to test that, right? But how do we test that? We need a Git repo. So I just created a random I created a temporary directory and I added some dummy commands to create a Git repository. And then I yield it. So any command that executes in this repository will have a Git repository. Okay. In this directory, we'll have a Git repository. And yeah, I think I should have nested this inside a try finally block, but that's fine. Okay, so I made animations to show this, but yeah. So then I execute the commands, I yield, and I change my directory back to my original. Okay. So with that, the last part of the talk is about pytest and pytest fixtures, right? So what's a fixture? A fixture is a function which will run before each test to which it is applied. So the fixtures are specified in the argument list of the test function. Fixtures are used to basically feed data into the test. For example, some input data or some instance of a class that you don't want to initialize in every test Okay, and you can also scope these fixtures. So it can be either module scoped or test or one function scoped or even package scoped. But I think package scoped is a little experimental as of now. But yeah, so it's useful when you want to module scope things, so that a particular instance of a class will be shared across the tests. Okay, and a few of the pytest fixtures that are available by out of the box are something called capsys. So it captures the std out and stdr text, and a testdir provides a temporary test directory, temp-path, tempdir, and yeah, that's a few of the fixtures that I have added. You can see more on the docs. Okay, and coming to custom pytest fixtures, you can actually define your own fixtures by using the @pytest.fixture decorator. And so this is just a fixture that returns an SMTP call to some server. So wherever you use SMTP, you will always get that same this one a call. So basically, it's feeding data into this test EHLO, right? So this is one of the fixtures that we have written in our Jovian library. So it basically scopes it to module so that there's only one CLI runner. So there's only one instance of CLI runner that is there in the entire for that particular test CLI module. Okay, so that I don't have to run this code in each and every test, and I can just pass in this runner argument into the test, and it will pick up that instance. Okay. In fact, there's some redundancy here. You can just return CLI runner. Okay. So next is parameterize. Parameterize is a mark. It's a label that you can do where you can provide all the different types of inputs, all the different types of test cases to one test function. Okay, so you can assume here that eval is some function that I have written, and eval just takes in some input and it spits out the expected value. I mean the output, and it's asserted against the expected. 1 month okay. So so these are the different these are the 3 test inputs. So 3 plus 5 should give 8, 2 plus 4 should give 6, 6 plus 9 should give 50, 6 into 9 should give 54. So you can give anything here, like you can give how many arguments you want in this string, and that exact string should go into the test arguments as well. And this is one of the places where we have used parameterize. So it's just to test that a URL join is working properly. So you can see the different test cases that we have here. So if you weren't to do this, you would have to actually write either a for loop that goes through this, or you would have to write like thousands of assert statements, and that's not maintainable, to say the least. Okay. And with that, I would like to conclude. So use pytest to write efficient and maintainable tests, and you can read more about it in the docs at docs.pytest.org. And use context managers to form setup and teardown functions. And also use pytest plugins like pytest-cov to calculate code coverage on your tests. And try to bring the coverage at as close to 100% as possible. But note that if your coverage is 100%, doesn't necessarily mean that it guarantees no bugs. It just means that you can sleep at night knowing that you have tested every possible logic path in your code base, but still it can fail. So, all right. And with that, I'd like to show a meme. You wouldn't want to fix your unit tests to pass your code, because then you're like, it's like the blue pill life, because you're you're modifying the reality to suit yourself. So what you should do is instead you should fix your code to pass your unit tests. Okay, so don't do it the other way around, because then there's no point of writing the unit tests. Okay, and that's it. I'd like to take questions if you have any.
Nice,
So
man.
there's-
Thank you so much. First of all, let me just say I would have clapped if this was a physical meetup for the puns. Okay, I like puns a lot, so thank you for the puns. And the meme is appreciated, of course.
Yeah, I have more. So
And
We have reactions in the Zoom, so if anyone wants to do virtual.
yeah, and James Powell is always like an amazing resource to throw in, because the amount of things he packs into one talk is more than you can get out of 3-4 talks.
Yeah, absolutely.
Even if you don't understand everything, I don't, pick up some things to go and look back. Which which is what I would say to everyone here
Correct.
about this talk, because there has been a lot of content, okay, and you've done it enough justice as much as you could in the time that you had. Okay, so
Yeah, exactly. Yeah.
thank you so much for that. What I would really encourage everyone to do is actually look up all the slides, which will be available later on, I'm sure,
Yeah.
or the video on YouTube, and just pause wherever required in the talk and look it up, look up the concepts, try mocking yourself, try monkey patching, try. I mean, he hasn't mentioned that here,
Yeah.
but that is part of it here. And don't take Rohit's word for it, right? Try to see if unit test is really as bad as he says he is. I mean, he didn't say it's bad, but he's pro.
I'm biased. I have to say I'm biased.
Yeah. So make up your own minds. And that said, I am still very pro pytest. So
Thank you.
so that does anyone? I think there were a couple of doubts. Let me just scroll up.
Yeah.
So the questions I had was: is the assert line considered one unit for testing, or is test add function considered one unit?
Yeah, the function is considered as one unit, and that's exactly why it's bad, because again to throw shade at unit test, you'd write many assert statements in one test function, but that will run as one unit. So if any of those single assert statements fail, the entire test will fail. To answer your question briefly, the test add function is considered as one unit.
Also, Mudit has a comment. He says you can run tests by a PDB, which helps a lot in test-driven development. Yes, that is
I use VS Code to run it with debugger. Yeah.
Right. So I mean, like IDs definitely make life easier. I mean, like you don't want to give yourself a handicap when you're starting off, but once you're a bit seasoned, like maybe 1 year worth of coding or something, you can definitely rely on the power of IDs to make your life a lot more easier. If does anyone have any more questions? I think we have.
Atola has another question.
Who? Atola has.
Scope. Okay. I hope you mean scope with the
fixture.
fixture.
In pytest, you are mentioning scope as one of the argument there. I just wanted to get understanding on that. I was not very much clear on that. Yeah.
Sure. So scope is usually, I hope you mean it with respect to the pytest fixtures. So if I were to just put a link quickly in the one second. So before that, I'll just tell you what scope is. So scope of a fixture basically says that should it be, if you don't define any scope, it'll automatically pick up that it should be scoped for each test. So that fixture will run for each test in the module. Okay, but if you scope it to be module, it will run just once, that fixture, and it will return that value to each and every test. It won't run that fixture every time. And you can also scope it to be package, which is experimental, as I said, which what it does is it creates that, it runs that one fixture once for the entire package as in a collection of modules. So yeah, I mean,
okay. Yeah,
I'll share a link here. Yeah.
For example, let me take a real world example. If I am developing a web application, there I need to connect to a database server.
Yeah.
Instead of connecting to a live DB server, I'll be having the fixtures.
Correct.
There I'll be and this data will be available for all the modules if I didn't specify any scope, or else to a particular package I can scope it out, right?
Yes. I mean, you can write a fixture that returns that returns the mock containing all the necessary attributes for that DB connection, and that fixture can be scoped to either module or just a test.
Oh yeah, got it. Thank you.
Hey, I just want to make one point. Really nice talk, by the way. Well summarized in the time that was there. So I just want to. I'm a pytest user myself. I found one feature which I ended up using a lot, and I just want to share my thoughts on that. So there is a pytest assert wrapper, which is a hook actually.
Okay.
And that so pytest has hooks where you can define certain functions which will execute at certain times.
Yes.
And because pytest rewrites the assert, rewrites the the assert is actually rewritten when it goes through all the modules.
Yeah.
You can define a function which will compare the left and right side, LHS and RHS, and write a lot of code which will help you find out the exact difference between two objects. And you can define it per type and stuff like that. It's a phenomenally useful feature.
Yeah, I think you can say that about Python in general, because you can actually hook into any process in any function with the dunder method. So for assert, it's dunder assert and stuff like that.
Yeah, you can do it with EQ, underbar EQ.
Yeah, sorry, dunder EQ. Yeah, exactly. Yeah, I've put up the link for the scope thing on there. If there's any more questions, I can.
Sai has a question.
Okay. I'm putting a.
Let's read it out. I mean, like for everyone.
Yeah, sure. So Sai is writing APIs and he wants to test for the put request, but for testing put, he needs to post something first. So can you test both of these within a single test function?
Oh no! So
yeah,
this is where mocking comes into play.
Yeah.
Okay.
Exactly.
So if you want to put something, which means you want to update something, then you can assume the existence of something in the DB. Okay, I mean, like that's what you'll be doing a put on, I assume. So you can mock the existence of something in the DB, or have a spare have a what you call a pre-existing DB file, and then you can do a put on that.
Yeah.
Hey, Abhiram, I think he meant something different. I mean, that's how I saw it. So if post is a precondition to the put, and put is what you're testing, then post should happen inside a fixture, so that the fixture or the setup itself fails.
Right.
I think that is that the question, Sai?
Or actually, Sai, you since you actually are not sending these API requests over the network, you can actually directly test the put itself. Is what I feel, because at the end of the day, you're testing that a certain put action is called, and not actually it's a unit test, not a functional test. So when you write a functional test, you should actually do whatever it needs to do a put request. But since it's just a unit test, I think you should just test that the put request was placed, and the particular headers were there, the particular parameters were there, the body was there, stuff like that. So yeah.
So guys, we'll officially just break for now, but there's a lot of questions and queries on the comments, so we can continue for that. Abhiram?
Yeah, and we can come back at it's 11:43 now, so we can come back at 12 o'clock to start Praveen's talk. Till then, we can still spar about some more questions if we are available, or break and come back.
Phil has a question. Any particular cases come to your mind when not to use mocks? Yeah, very good question, because sometimes I have done this myself. I have gone overboard with mocks. So like my test function had like 10 lines of decorated patches. So and that's when I realized that the actual source code is not good. Anyway, so when not to use mocks is, let's say, when you're doing functional tests, obviously. So rather than unit tests, so you want to actually test that some function call or some API call was made, and otherwise I would prefer that don't use mocks for file creations and file deletions. Rather put it in a temporary directory, because file creation and file deletions are very critical tasks in functions, and you should actually test them properly. So I would say that try not to use mocks for such operations. For example, a contractor once wanted to mock most of the Azure Cloud API. You mean for the unit tests? Yeah. That's okay, because it's the unit test. But if you're writing other types of tests, then you shouldn't do that. How do we test network connection or reachability to a server That's again something you wouldn't do in a unit test. So yeah, I think that's something you do in a different type of test. But a unit test, you wouldn't actually connect to any server. Best practices on teardown of data. Just make sure that the state in the beginning is the exact same as the state after the teardown. So make sure that there is no side effect that your test caused, because what happens is that, let's say you change directory and you forgot to change it back, all your other tests will fail because the relative path failed. I mean, if you have relative path. So that's happened multiple times. I can speak from experience that when a particular test fails and the teardown didn't happen properly, literally every test that follows that test will fail. So best practice should be that make sure that your state prior to and after the test is exactly identical. I hope that answers your questions, Satish. Do we have more time for questions?
No, we have time,
Okay.
but there's also break time. So if you want to take a break and come back, that is also fine. In any case, after the next two talks, actually in between the next two talks, first at 12 o'clock, we have a quick announcement by Abhishek about PyCon, which is coming up soon, PyCon India. And the organizing team is here. So Abhishek, Anirudh, Ritesh, all of them are part of the organizing team this time for PyCon India. So Abhishek will be talking about it at around 12 o'clock. I want everyone to come back for that. So after these two talks, we'll still continue about the pytest topic, because it seems to be a bit of a, like interesting thing that people want to know more about. And now they have you, Rohit. So
I think I met Abhishek at PyCon India last year in Chennai.
Possibly.
Yes.
Yeah.
Yes, I do remember.
Yeah.
Satish asks, do we have any API today, pytest, to put a state restore point?
I don't think there's any automatic state restoration thing, because that's a very broad thing to consider. Because what do you mean by state? Do you mean the file system? Do you mean the in-memory variables? So I mean, I think that's...
No, I mean, yeah, I agree. And it is not something that needs to be delegated to pytest, I think.
Yeah, exactly. Yeah.
So I was, I'm sorry, this is Satish, by the way. So the context of the question is like, so you mentioned that we need to take care of tearing down the data and maintaining the state programmatically, right? So I was checking like if there is something in the pytest SDK, do we have any method that can put a pin on the state before and after the test run, so that we can smoothly handle the state restoration? That's what I was tend to ask.
Yeah, I haven't come across anything as such, but that's probably a good either feature to propose or to look for. You can probably raise an issue on their GitHub. Yeah.
Actually, there is some more to it. Hey, sorry, this is Praveen.
Yeah.
So there is no guaranteed way of ensuring that the state will be always restored exactly the way you want.
Yeah.
Because not only is it it's not just about pytest. You may even be modifying global state in your code which is under test, and there is like you never know. And all of these tests run in the context of a single process. So it's likely that there is some residue of a previous test and stuff like that. You can find out by running tests in a different order, or trying to do those sort of things. In many other languages, a common way to avoid this is by running it as a sub process. You run tests in their own process. So they start off, but you can only afford to do that if the tests run fast.
Yeah, exactly.
Cost also, but that is
one
way to avoid it.
Yeah, I clearly understand that that is actually most of the programming languages do. So I was thinking like anyhow, these kind of unit tests will be part of the CI/CD pipeline, right? So it will be for each and every commit. And since the objects are under our control, even like if you take mocking, the objects will be under our control.
Yep.
And if you can let the method or any method that can save the state, at least a completion of a unit test, that the objects that are specific to that unit test, if it can hold the state of it, and then once the unit test complete, and say for example an assert is complete, and if we can set a flag to restore all the objects to the same way they were, and I think it will be helpful for the other unit tests to work without any issues, and the unit test will be pretty clean and tidy.
Unit tests do work in isolation if you in a entire suite. So I don't see, I mean, like maybe I'm not understanding the question clearly, but I don't see how one test will cause a problem with another or to another.
I was just giving an example, not specific to any real world example. I'm just giving an example, like if that is a case with one unit test, or say if we have a group of unit tests that we are running in a class or something, then we can put a restore point for all those unit tests, and then like put back the, say for example, there are app settings, and if we are modifying the app settings in the unit test for a particular unit test to run successfully, and if you put back the app settings back in place the way it were for other unit tests to use it, maybe they don't need it to be modified. So that's something that I was asking. But anyways, yeah.
No. So then they need to be caught within the test itself, and you need to make those changes, those restorative changes before proceeding. That is part of the sort of cleanup that the programmer should ensure on their part.
And also, I'd like to add that Python is usually more of an explicit language. And if you introduce this sort of state restoration thing, even if it's possible, it is happening implicitly, and you might run into weird issues. So I think that to restore the state explicitly by doing it in the finally block should be the norm.
Yeah. Okay, sounds good. Thank you guys. Thanks for the answers.
Of not being able to do state restoration is like, let's say you have a class somewhere in your actual application code under test application code, right? And then you are making some operations, and then that code caches some data, right? And your test number 1 has done something, and it has ended up caching data. You have done your cleanup, but you don't have an API to explicitly reset the state of the cache, right? So now test number 3 is going to run with the
cache.
There is something in the cache. So there is no way to absolutely ensure that state will be cleaned in your entire application. That is so it's almost as good as having to test whether the cleanup works fine. So it's the equivalent of that. So
that is another test, I suppose.
Yeah.
What is it? I missed it. Sorry.
So the entire effort that goes into ensuring that the state itself is restored itself becomes a test problem, right?
Okay. Yeah. Meta test.
Yeah.
Well, thanks guys. Thanks for respecting the questions.
Abhiram Atta here. So this is my first session on Meetup.
Welcome.
I'm a member of Bangpypers since from 2008, but I was unable to attend any calls. This is very much a helpful session. So one quick question I had, Abhiram. So with respect to test, right? Long back we were using a test tool called nose test. Are there any updates on that tool, or what is the status of that library?
Nose has now been, like supersetted by many of these projects, I think. I mean, I don't know off the top of my head, but I like when I was doing my comparison for which testing utility to pick up, pytest seems to be the superset for everything. So maybe like Rohit wants to comment more, but I don't think nose is very relevant now.
Yeah, that's why I didn't even mention it. So
now there is nose 2 actually.
Oh, there is?
Yeah, so that is comparable with pytest. It has the same features of pytest.
Yeah, but I feel like pytest has a broader community that maintains and develops. I mean, I can be wrong, but I feel like pytest is
Oh wow, okay. In the nose to documentation, they say nose to may or may not be a good fit for your project.
Yeah,
If
there you go.
you do Python testing, we encourage you to also consider PyTest. Like it is very humble, like it also almost makes you want to try nose to now. Nice. No,
Okay.
thank you, Anirudh. I think here, Atay, I think this is what you're looking for. And you know what? I'm going to try out nose 2 after this. And we'll have a comparative study of both.
I think like we missed Mohsin's comment, or it's not a question, but he says, I normally use in-memory DB to test actions of DB. For instance, I would put a post request in fixtures and do put later.
Oh yeah, yeah. So
he's answering the other question. Yeah.
Yeah, same thing as what Praveen said, and actually, you're right, Praveen and Mohsin. That is what I intended to say. I mean, mock wouldn't be suitable in this scenario.
Okay. Yeah.
So there is Anirudh's question that we missed. Any ideas on PyTest Spark, or is there a better module to test PySpark code? So PySpark code, I've been working with PySpark for a while now, and in terms of testing it,
would normal PyTest not work, or what is the problem?
It does. It
No,
works.
It would. So let me give some context. So I mean, I've written PyTest for PySpark. What I generally do is I basically create a sample Spark session object with some data in it. That is, so basically it's like a manual mocking which I'm doing. So I'm creating a Spark session with some data in it and then doing the test. So I just wanted, I have not used this PyTest Spark module. I just read about it recently. So I just wanted to know if it does anything differently, or is there any better alternative rather than creating our own Spark session for testing?
See, the way I have rationalized it for myself, actually, let me tell you that I have been doing the exact same thing. I do the same, what do you call it? Setting up my entire small Spark session and testing out all the transformations and actions so that I can figure out how much memory is being used and all of that. Okay. And the way I rationalize it is I want to know how many executors are required and how much executor memory is required and all of that. But I've never thought about it from a automating standpoint, because the number of tests have been less, but the number of the configuration payoff, like in terms of fine tuning, it has been higher than me having to automate it. So I think it's a good probing question for when everything is set in place and all you have to do is run those tests, right? Because these are long running tests. If your data is high and these collect operations are expensive in nature, these actions are expensive in nature because of the lazy loading, the lazy work that they do in advance, right?
Yeah.
So I think there's a long-winded way of saying we should experiment. I don't know.
Yep.
Yeah. But Anirudh, if you do find out, looks like you are looking for it, I would really appreciate it if you got in touch and let me know. And I would also.
Sure. Yeah. Thanks.
There's a question on multi-threaded applications. What are the best practices for testing a multi-threaded application by Raj? If anyone wants to answer, feel free, but I can also answer.
No, go for it, Praveen.
Best practices, I mean, it depends on how you are utilizing multi-threading in your application, but yes, there is a need to test for it. And a good practice is to know how you want to intend the cleanup state. For example, if your code is going to spawn multiple threads, but at the end of a certain operation, you expect that all those threads are going to join back, then you must write some code to explicitly check for it. You would also be very careful about whether you are executing code which just spawns more and more threads, because then if you just run a test which ends up executing that code path, and you're just spinning more and more threads as your test evolves, as your test executes. I mean, a series of tests execute, then that could be a problem. So yeah, so you have to care about what your application does with respect to multi-threading. Are you simply spawning threads? Are you using a thread pool of some sort, like a thread pool executor or something? Yeah, you have to pay some attention to what is happening.
So we have like a open house time at the very end as well. So we can discuss about multiple stuff in there. So Atala, if you can just hold on to your questions till then, we'll be starting with the next session now. Abhiraj?
Yeah, and that session is, of course, Abhishek. Abhishek, please, you can take the stage and talk about PyCon and what we can expect.
Yeah, what is PyCon?
Give me a moment. I would like to just share my screen and then.
Yes, please.
I hope my screen is visible now.
Yes.
Yes.
Okay. Good afternoon, everyone. Well, it will be a morning for some people like me. I usually wake up late. So my name is Abhishek, and I am a part of PyCon India team. So if you don't know what exactly PyCon is, so I'll give you my sort of personal definition to PyCon India. It's a sort of festival for all Python developers across India, and not only India. Like there are people who also come from other countries as well. So basically, it's an annual conference primarily focused on Python. So all like-minded people and the people who are contributors to Python, and then people who contribute to the Python community. So we gather together on conference day, and then it usually used to be happen like physical conference, but as you know, since the pandemic is there, we are like moving it to online. And so the dates for PyCon India 2020 are from October 2 to 5. So initial 2 days, that is from October 2nd and 3rd, the conference talks will be there. There will be a lot of talks in parallel as well. And then from October 4th, we have workshop. And then from 4th to 5th, we have a dev sprint. So, let me just give you more information about that. So talks, as you know, it will be like a normal talks, whereas in workshop, of course, hands-on practicals and all stuff will be happening. And dev sprints are like sprints, like where open source contributors who maintain the project can come together, and then people who really want to contribute to projects, they can join together and hack around it. So they can solve the issues and then do PRs and all. So open source contribution basically with particular project one day. Currently the talks or proposals for PyCon India are open. I guess there are only 27 days are left for the deadline. Deadline is in August. And there are a variety of tracks actually. If you would like to submit the talks, it can be related to Python. Of course, the conference is mainly focusing on Python, but it's not only restricted to Python. You can also give a talk around the software culture, the diversity part, and then, for example, if someone want to give a talk on like how empathy looks like in software engineering, or the viewpoint or perspective of that from a developer, or some good practices for developers. So those sort of talks are also welcome. So if you go to bit.ly/CSP-PyCon India, it will redirect you to our CSP portal. You can go around there. We also have a blog, how you can write a nice CSP. There are list of best practices available. And then the best part is PyCon India is not only looking for experienced speakers. First-time speakers are always welcome. And we are also providing mentorship for them if people are having doubts. For example, if you have a topic in your mind to give a talk on, but you are not sure how you would like to represent it, do contact us. We would be like really happy to guide you in that term, like how you can present a talk. So already there is some sort of best practices available over a portal. You can go ahead and then, can draft your proposal accordingly. Apart from that, we are also like looking for volunteers, and if even if you are not want to volunteer, you want to have some sort of discussions around PyCon India, or you have some good ideas that can be incorporated in our conference, so you can join our Julep chat. It's pyconindia.julepchat.com. But just to keep it a short, I have attached a bit.ly link here. You can just type in bit.ly/join PyCon India. So in coming to part of volunteering, we have a different work groups. We have work group for promotion, CFP team, review panels, mentorship team, and content team. And all these channels are open on Julep chat. So once you join the Julep chat, it is just like a Slack, but in little scale. So you can join streams, basically channels according to your choice in which area you want to contribute to. Feel free to introduce yourself. There are people around you. If you are not sure where exactly you want to contribute, let me know, let Anirudh or Ritesh know. They will be also helping you on that. So this is a website for PyCon, in.pycon.org, and this is our Twitter handle. So follow us to for more updates. And if you wanna contact me, this is my usual social media handle, or Twitter and LinkedIn. You can contact me, and then of course Anirudh and Ritesh and Abhiram are there, so definitely they would also help you. So thank you and stay safe. And if I have missed anything, Anirudh and Ritesh, please feel free to take this forward.
Anybody have any questions around what PyCon India is, what happens in there, and so on?
You can go to previous year website as well, and we have uploaded all those pics as well, pics and videos of whatever happened in conference, the list of talks, all sort of things. And one more thing, if you don't want to give a talk, but if you want someone to see giving a talk, let's say for example, Rohit gave an amazing talk today, right? And if you want a person, like which gave us a nice talk, just like Rohit, you can probably ask them to, hey, why don't you go and submit a talk to PyCon India? So you can at least help us in that way again. So that would be a great help as a community. So yeah, so if you know someone who's really good in doing stuff, you can just ask them to do a talk, and same applies for a workshop and dev sprint. Yeah, so if you have any questions, please let Anirudh, Ritesh, and Abhiram know about that, and then you can ping me again. No, not in here. So I'm stopping the sharing. Okay, so probably you can take it forward. Yeah.
Yeah, Phil is asking, is it going to be online? Yes, Phil, it's going to be online. The details will be shared later on the website, so you can maybe follow up on that. Yeah, and the talk submissions are still going on. We are looking for good speakers around who will be submitting talks. In fact, Praveen here will also be talking around one of the good topics that he has submitted in there. So you can also take a look at the proposals existing on the bit.ly links are shared here. So
and one thing I forgot to mention. So we have a CSP portal called Junction. If someone is like willing to contribute to open source, but they are like not sure whether to in which domain to start, you can actually start contributing to our own platform called Junction, which is a CSP portal. So there are a lot of issues and then feature requests. So you can probably give you hands on there. So it's based on Django. And there are people around it to guide you to set up it locally if you find it tough. So you can contribute in that way as well. Not an issue.
Absolutely. Thank you, Abhishek.
Yeah.
Okay, so we'll start with the third talk now. Praveen, are you there?
Yeah, I'm there.
Okay, just check if you can share your screen. So Praveen has been a veteran at Bangpypers. He has given multiple talks before, and we are so glad to welcome him on an online format. Praveen, over to you.
Hey, thanks. Hey, is my screen visible?
Yes.
Cool. Okay, so this talk is on Pythonic interfaces, just a fancy title. So I was planning to give this talk at PyCon India. The talk I'm going to give today is going to be a slightly shorter version of that talk. And that's mainly because I also want to show a small demo of how things work. So let's just get started. Um, so what really is an interface? So this is the Wikipedia definition of it. Uh, so an interface is a shared boundary across which two or more components share information, right? The key points are the fact that it's a shared boundary and there are more components who are talking to each other and they are exchanging information. These are all key aspects of the definition. Right? And let's look at a very simple example of where you would want to use interfaces. Okay, so let's assume that there's an application which has a component called a data processor, and the data processor needs to do read and write operations, and the read and write operations are actually provided on some other class. These are all like file-like operations, right? You typically read and write on a file or something like that. So the data processor depends on some file-like object, and this file-like object is what's going to define the read and write operations. The data processor is the one that calls these functions, methods, right? So let's look at a very simple example of read and write. Um, so you have a read method, and it takes size as a parameter, and it returns the bytes that it has read. And if you say read 10, that means it's going to read 10 bytes. By default, we're going to pass -1, which means read till the end, till end of file or end of whatever stream, end of the data source. Write is the exact opposite. You give it bytes, it's going to write them, and it's going to return the number of bytes that it wrote, which is actually the length of data, actually, right? So there will obviously be more such methods like close, seek, and stuff like that are all file-like methods on a file-like object. But I've just restricted it to these two for the sake of example. Okay? So you can have many implementations which sort of obey this same methods, right? So let's say we have a file IO class, and this does the same thing, but it does it on an underlying file. Similarly, you can have a socket IO which performs the same thing on a socket. You could have an in-memory bytes buffer, and you could have the same methods operate on a completely in-memory byte buffer, right? So what you can observe is that the method definitions are exactly the same, right? If you go back and see, nothing on this part has changed, right? The intended behavior is also the same. So if you say read, what read is supposed to do is the same in all of the implementations. What write is supposed to do is the same in all of the implementations, right? So only the implementation that varies, right? So how does this matter with respect to building large applications, right? So today, let's say you have a file IO class. Tomorrow you may have a better version of the file IO class with a much better implementation, much faster implementation, right? And you would want this better implementation to replace the earlier implementation, and you don't want too many headaches when you want to replace this. And you will have hundreds of such components in applications, and you want to be able to plug and play better versions and so on, and not have to worry about who calls this method, how is it called the right way, is the behavior exactly the same. Obviously, you can achieve all of these things by running tests, but if there is a way to minimize that headache, well and good, right? So that is the problem we are trying to solve. So today we're going to explore the method definition part, right? So why is this a concern, right? There are many ways to implement methods in Python, and how you interact with the class implementing the methods, it depends on how the methods are defined. Or you could look at it the other way also. You will define methods in a certain way so that the interactivity is done in a certain manner. Okay. So like if you just glance over all the things that you can do with respect to defining methods, you will see that there is quite a lot, right? So first thing is the name matters, right? The name of the method matters. The signature, which is this, matters. If you do type annotations, the type matters. The sequence in which you supply the arguments matter. Whether they are keyword arguments or positional arguments, they matter. And all of this, whether it's a method, whether it takes self as a first argument and all that also matters, right? You could also decorate methods with these static method and class method decorators. They also have a specific meaning. A static method is just meant to work like a function but bound to a class. Class method takes the class as the first argument instead of the instance. Then you have a property decorator for managing data, right? And if you use a property decorator, then this method is not callable, though it looks like a function. You're not supposed to call on it. And if you define a setter on this property, then you do assignment. You don't call. This is not this bar is not supplied as an argument to the foo setter, right? It's assigned. And you could also have a generator function which yields. So if you do a yield, it is very different from a function doing return, right? You can also have async, and that's again going to work like a coroutine and so on. So there are so many nuances to how you define methods and their signature, and how you use them also varies based on how you define them, right? Is there a way in which you can enforce all of these things? So what we are looking for is a method through which, any mechanism basically, through which you can ensure that all the required methods in a class are implemented with the correct names. You want to ensure that they have the intended signature. If there are decorators like static method, class method, property, etc., they're all honored. If some of the methods are generators or coroutine functions and so on, you have a way of finding them out to ensuring that the implementation also does that. And anything along those lines. Basically, what you want is you have a class which is a blueprint, and then you have implementation classes which could be many, and all of the implemented classes match the requirements of that blueprint to the T, to the greatest degree possible. And that is something that you would want the code to enforce, and that way you have one less thing to worry about. So there are ways to go about it. We'll look at two large categories. One is the passive way and active way. I mean, these are not technical terms. These are just names that I made up based on how they're invoked, right? So passive way of checking things is you separately trying to verify whether things are fine, right? That could be done by, say, linters or mypy or any of these tools. Basically, they could be static analysis tools or tools which actually dynamically check as well. Like for example, runtime checks. You could run unit tests to verify whether the methods are implemented correctly and things like that. You can do a lot of checks, right? The main differentiator here is that the checks are not part of the application. You are actually going to invoke these checks at a certain point. They could be on change of code. They could be, if you're developing, you may want to run this as and when you're developing. It's not meant to be part of the application. It doesn't ship with the application. They're separate and they're invoked separately. Right? You can also have active mechanisms. So active mechanisms are ones where these checks are actually part of the application. They are part of the application code and they execute as part of the application code, and they're constantly enforcing these sort of checks. A good example of that is the abstract base classes in Python, and they execute when the application executes. Right. So let's look at abstract base classes, because this is one of the most widely used methods, and it's been there for a long time, and that is the reason why it is very popular. If you go on the net, you will find a lot of literature related to this. So we'll look at this as an example. The way you use it is by importing this package called ABC, and ABC meta is a meta class which enforces behavior on the various implementation classes that you have. And you enforce that using a decorator called abstract method. Okay, and the way you would go about doing it is you will define a class which is meant to be a blueprint, and this will have the meta class set to ABC meta, and you will define methods within this meta class, which is your blueprint, and decorate them with abstract method as a decorator. Now, these implementations need not have any implementation at all. In fact, ideally, this should simply say pass. I've put raise not implemented here, but the blueprint should only have the methods, method definition, and no implementation inside it. That's how it is supposed to be done. Even if there is one, it doesn't matter, because you're not going to create an instance of IO meta. You're going to define other implementations which use IO meta as their parent class. Okay, so the way you would use it is,
Praveen, shall I stop you for a minute?
Yeah.
Okay. I earlier I was under a discussion with one of our mate, saying that there is always an argument between whether we use pass or rise.
Yeah.
So which one you prefer? What is the recommended way?
The recommended one would actually be pass. Earlier, there used to be a lot of discussion on wanting to be very strict and raise not implemented. But there is a whole talk by Raymond Hittinger where the same question was asked, and he has also recommended using pass.
Using pass. Okay. Okay. Thank you.
Yeah. So if you were to implement it, then you will have your actual implementation derived from IO meta, and that's about it. And then when you create an instance of this memory IO class, at that point the ABC is going to kick in, and it's going to check whether you have implemented the read and you have implemented the write methods. And this is how the ABC works, right? But there are some limitations to ABC, which is the fact that the check is actually done at the time of instantiation, and it's not a limitation, but it is a sort of by design. And that's again because Python is very dynamic. It's not that like you don't have to always define methods ahead of time. You can also patch methods to a class. You can implement underbar, getattr, and define dynamic methods and so on. So there are a lot of ways in which you can play around with Python. So the philosophy there is that any such checks are done at a very late stage, just before you create an instance and start using that instance. So that is why the checks are done pretty late. Right? But a real limitation is the fact that these signatures are not checked in abstract base classes, and that is also because the abstract base classes are pretty old. So the abstract base classes have been there since Python 2. They are there since, so they've been there for even before the type annotations came in and so on. Even before the signature check support came in, and they were implemented for a very different reason. The goals were different. If you'd like to know more about it, I would recommend looking at this talk by Raymond Hittinger, which was given at PyCon Russia in 2019, where there's a lot of Q&A around this topic. Right? And the reason I've picked abstract base classes is not because of its limitations, but because ABCs are the primary library that get discussed in this topic whenever you go search the net for some literature on how to work with abstract classes or interfaces and so on. So you will see a lot of example code already out there which uses this. But if we start looking at what is available today, you will find that Python uses type annotations, gives you an option to utilize type annotations heavily. And there is this inspect library which has evolved a lot. There is a lot that you can do with inspect in terms of determining certain behavior and also writing some code to enforce certain behavior. And inspect has really kept up with the time, and this is really worth looking at if anyone's interested in it. So there are a bunch of libraries which tend to use inspect internally and to give you some nice functionality. So there are some third-party libraries that you can use to enforce interfaces. A very popular, I'm not sure how popular it is, but it definitely is a very old one called zope.interface. It's been there for a long time, several years. It's on version 5 now. It has lots of features, very verbose, rich API, but it's slightly more complex in terms of usage. You will need some time to absorb how it works before you can leap into it. Then there's a library called Python interfaces, which is also pretty nice, really simple. It has got a very modern interface implementation. It supports Python 2 and Python 3, and it uses meta classes similar to how ABC uses it. The advantage of using meta classes is if you have a lot of inherited code, then if you use the meta class approach, then every subclass will automatically be part of your enforcement logic. So if you have memory IO, right? Now, if you have a new class which derives from memory IO, that automatically, because it's all part of the IO meta chain of inheritance, it will also end up obeying the enforcement for read and write. So that is one thing that you get automatically by way of using any mechanism which uses meta classes or inheritance. So these two libraries, and at least Python interfaces definitely has support for it, and that is how it is intended to be designed. Third library is called implements. Sorry, I see a spelling mistake here. It's implements anyway. This is a fairly simple library, really just one file actually. All the implementation is in one file. It supports Python 3.6 plus only. That's because it uses a lot of features from the inspect library, which are available from Python 3.6 onwards, right? And it also uses composition over inheritance. This is an entirely new. It needs it needs 1 hour on its own, so I'm not going to get into this. But it uses a different way of achieving the same. I mean, in fact, I would argue opinionated that it achieves something better. So we'll look at this library today. So before I get into the demo, are there any questions so far?
Don't think so, Praveen. You can continue.
Can you tell me how much time I still have left?
You have like enough time to play.
Okay, all right.
Yeah.
Okay, so just let me know when you're able to see my screen in full. Is the
Yes,
font?
yes.
Yeah, all right. So what we are looking at is a very similar example to what we already discussed in the presentation. So we have this IO meta class, and it is using abstract base classes to enforce the signatures and the methods. Not signatures, just the methods actually. So I have read and write, and I'm using abstract method decorator over here on the read and write methods. And this is my implementation. So test.io is my implementation, which is deriving from IO meta. And this is the actual implementation that's over here. And in my code, in my actual application code, I'm creating an instance, reading, writing, just for the sake of it. Now, if you try to run this, let's do that. Okay, this is a simple way of running it, right? So you can see that it read 5 bytes, it wrote 2 bytes, and so on. Now, if I didn't implement this method, right? If I didn't implement this method, then I get an error. So this is the enforcement logic. So the ABC meta is telling me that I cannot instantiate test.io because I have not implemented an abstract method. So, and in that case, the one that is indicated here is the write method actually, right? And you can also see where the error is being raised from. It is in line number 34, which is at the point of instantiation of the class over here, right? Let's just speed it up a little bit. So okay, so the write window is going to keep running every time I make modifications, right? So if this method was implemented, things run fine. Okay. Now, if I make changes to the name of the variable, it still runs fine, right? So the signature is not at all checked, right? So so if I defined a new, if I defined a different method with the same name but a completely different signature, things still work with ABCs, right? So this is a limitation we need to sort of tackle. And for that, you can use a library called implements. So what I'm going to do is, so implements, the library has two things. One is the implements decorator and a class called interface. This is actually a dummy class. Currently, there's no functionality inside it. But the way you're supposed to use this is, you're going to call this an interface. Okay, and remove this, and let me remove this, take this back to how it was. All right, so the blueprint derives from interface, And then in the blueprint, you can define all your methods, all your signatures the way you want it. And the implementation is not going to derive, but instead it's going to get decorated. Like so. So you're going to have an implements decorator which says this class implements this interface, right? And that's what it's supposed to mean. And you will see that there is no inheritance involved. If this test IO was inheriting from A, B, C, or whatever, there are no changes to it. In fact, test IO does not even know that there is some enforcement logic outside of it which is acting on it. So that is the sort of advantage of composition over inheritance, right? That is what it's supposed to give you. Now with this in place, let's see what happens if you change the signature. Now, I have just changed the name of the variable, and it still complains that there is a mismatch of the interface. Right? So not only is it checking for the name, it is checking for the entire signature. So if I say omit this, or if I change this to bool, it's going to raise an error, right? If I match it, then things work fine, right? So this entire thing has to match exactly as is, right? That's a requirement. The other thing is, let's see where the error is raised, right? Now, even if I don't do, okay, and if I say this is bool, it doesn't matter whether I instantiate or not. The check is done on import because the code is over here. The enforcement code is over here. The check is done on import itself. So even before you get to instantiate the class, all your checks are done. So the earlier you get to know of errors, the better it is for you. So this is also a plus point. And the other thing is the enforcement code is very close to your implementation code. So you straight away know that this implements this. Whereas if you are doing inheritance, the meta class could be in some other file somewhere else, and you would not know about it. You would know about it when you instantiate, but you will not know it when you're like going through the code or looking at it in your editor and so on. Right? And let's try to enhance this to some other things, right? So let's make it. Let me define a new class. Okay, what happens? So now it says this is a static method, but this isn't, right? So if I say int, right, is missing one positional argument. Because the static method does not require self, right? So if I change it to class method, so that the error is being raised from here because of the call actually. Right? But even in the static method case, it basically matched both the arguments. Right now, again, you see that the class method is matching it, and so on. Now, if you had a method like this, say, right, and you implemented so even over here, it is able to detect the fact that something in the interface was defined as a generator function. You are actually yielding from it, but in an actual implementation, you are doing a return, right? So this is also caught. A similar way, you can also have return and say async, but you forgot async over here. That is also caught. Right now, it's a coroutine function. So something is a coroutine function in the interface, but it is not in the implementation. So there are a lot of these checks which the implements library can actually detect for you. You can obviously implement more things in your implementation. Like for example, you can have something too over here, and that's not a problem, right? So you can have more things in your implementation, but whatever is defined in the interface must be implemented by the implementation exactly the way it is defined over here. That is the goal, and that's what this library helps you achieve. So that is the end of my talk. So I can be contacted by mail or on any of these platforms. I am not on Twitter by design. Nothing related to the new latest Twitter fiasco. The content for this talk is available here. The presentation of this talk is not yet visible, but all the slides, all the content that formulate these slides and this code will be there at this place. So I can take questions right now. Just before I get there, the implementation library is available here, github.com/k-sindhi/implementations implements. Kamil Sindhi is the person who is the maintainer of this library. I'm one of the co-authors, one of the contributors. Yeah, we are again looking for more people to use this and tell us if there are any deficiencies that they found. Right, the entire implementation is in just one file called implements. The tests are pretty exhaustive, so you can go through. The implementation is just so much, right? The whole thing, and there are a lot of tests which check for all these conditions and raise some exceptions and so on. So if you would like to see how to use it in ways that I have not demoed, this is a good file to go through to see how to enforce it. And there's obviously support for things like breaking down the interface to smaller interfaces and so on. Like for example, you cannot have read and write as part of a single class. You can have a reader. This could be called a reader, and this could be called a writer. Right? And this is the ideal way to segregate interfaces as well. So that's also supported. So yeah, these are the files that you can look into if you're more interested. Feel free to get in touch with me in case you have any questions or doubts. Yeah. Thanks.
Thank you so much, Praveen. Do you guys have any questions? Just share here. One question here, Praveen, is like, what are you using to run the code automatically?
Okay. So there is this tool called Enter, ENTR. Okay.
All right, so I think somebody shared, Rohit has shared here, I guess, the link of Enter.
Yeah.
Okay.
So,
and yeah.
Yeah. So Enter watch for files, and then it will run. It's a TDD tool. Yeah.
Okay. Do you guys have any more questions? So Rohit says that he needs your dot files. Me too, by the way.
Dot files. Okay, I can share it maybe after the talk. I don't have many. What I'm using is actually a tool called Workbench, which I wrote earlier.
That's fine, then we can come back to this later.
Yeah.
If you guys don't have any more questions, or you guys can please leave your questions here as well. Okay, Udyan has another question. Can you just check it out? Can you explain a bit about self size? So the your code snippet part.
Yeah, sorry, I'm just going through the chat now.
Udyan, you can also unmute yourself and ask directly.
Yeah, I prefer that actually. Yeah. So
I guess Udyan is not vocal right now.
Hi, Praveen, can you hear me?
Yeah. Go ahead, please.
Yeah, so basically my question is, so we don't have any like typecast, like the input should be or the return should be. So what does this statement actually mean? So basically it means that the input should be an integer and the return type should be in bytes. The double hyphen and the slash bytes, which is mentioned.
Right. Yeah. So if I put a colon over here, and if I mention a type here, this is a type annotation. This is not enforced by Python. It is just a hint to Python. Python is still a dynamic language, so Python does not enforce it. But you can indicate that this variable is meant to be an integer. Okay. And this is how you define it. And this is a Python 3 feature.
Okay. So this is just an indicator feature, not.
Yeah, this is just an indicator. And there are tools like MyPy, which can actually check for this, but Python as such does not check for it. So if I simply run Python this file, this will have no effect on it.
Okay.
Okay.
Got it. Thank you, Praveen.
Yeah. But if you're trying to do inspect or if you're trying to introspect your code, you can derive the type. You can identify the type, and maybe you can write your own logic to match things and so on.
Yeah. Thank you.
Yeah. And this indicates the return type if you do a grade.
Okay. Yeah. Okay.
Awesome. So Anirudh also shared, the other Anirudh also shared the link of the typing library. So you can just check it out. Okay, so thank you so much, Praveen. It was amazing. We had lots of fun. Hopefully you will probably head back and we can discuss more on this after the fourth talk.
Sure.
So the next talk is by our very own Abhiram. He's been co-organizing Bangpypers for the longest time, and will be talking about code quality and practice tools with some extra features that he has also worked upon. Abhiram.
Yes. Hello. Okay, so I'll share my screen again. Thank you, Praveen. It'll be a tough act to follow, but let's do this. Can you see my screen?
Yes.
Okay. So don't mind the choice of color. It's bad. But yeah, so this talk is basically about code quality. Okay, the practice and the tools. But the first thing to ask is, what is code quality, right? And this is a very subjective thing actually, because if you look at your code, you think, and if you're a very opinionated person, you think your code is very good. Okay, and if you look at someone else's code, and if you are opinionated, you think your code is the best and everyone else's code sucks. Okay, so that is a very narrow-minded way of looking at it, but it's also one way of looking at it. Okay, so code quality can mean different things to different people. And here I've tried to bifurcate that into different factions that are that we work with on a day-to-day basis. So main thing is, who are we writing code for, right? Either we are hobbyists who write code for ourselves, or we write code as open source projects, okay, where we are writing code for either public usage or companies to take it up and expand on it and stuff, or we are writing code for proprietary usage for businesses. The third sector was the biggest sector for the longest time, but now open source is catching up. Hobby programmers is not as much as we would like it to be. It's easy to see why we might think that it's a lot of people, but it is still very much low in comparison to the first two. Thankfully, the first two and not just the first one, right? So, but here when we're talking about writing, where does code quality most come in the picture, right? When you're writing code in your company, that's when it subjectively matters the most. So to business, it might just mean like time to market and accuracy, like how fast can you get it done? That's what the stakeholders will ask you, right? But that is not considering how good the code is or how efficient it is. Efficiency might also come in the picture, because that is reflective of how much time the code will take to run, which directly reflects in how much time it will take to ship the product. And to a data scientist, it will mean the quality of models, because to a data scientist, it does not matter if a code is neatly organized or if the modules are all set in place and all of that. All that matters is finally when my models, which are doing the prediction and training and testing and all of that, do those models have the actual the proper values that I am looking for? Does my random forest algorithm give me the correct number of correct accuracy, or does my XGBoost algorithm give me the proper confidence matrix? Okay, so that is what matters to the data scientist. So for him, the code quality is different, right? And to a developer, which is closer home, it is a bunch of 4 things that I've chalked out. It's modularity, or correctness, or performance, or readability. Okay, well, we'll explain each of these in detail, and that is the bulk of today's talk. So modularity is it can be automated, but it is very much a very intuitive process that a developer has to go through to learn what to segregate. Okay, it's like separation of concerns is something that you have probably heard of a lot. Okay, what does that mean? It's like if you have a function, it must do only the task it is designed for. How many of you have watched Rick and Morty? I mean, like I would have asked this in an audience and people would have raised hands. Okay, so Rick and Morty is an animation show which is admittedly not for kids, but there's an episode where the scientist, the protagonist, makes a robot, and its only task is to pass butter. Okay, he makes a robot and its only task is to pass butter. Okay, so and the robot feels bad, of course, in that episode. But what I'm trying to get at is you need to separate out functions to do exactly what they are supposed to do, so that when something goes wrong, the damage is localized only to that function, or if something goes right, what is exactly happening in which function, right? So and also in a bit to reduce complexity, right? So you don't want to put the bulk of everything in one function or in one script and run everything. It's just a huge amount of mess, right? And not just in terms of reading, also in terms of execution, in terms of debugging, all of those. Okay, so modularity is very important, and it is still very much a manual process, I think. And you can automate it, but I would like it to be a manual process, because who knows better than the humans, right? Like I'm all for singularity and for our overlords to take over, AI overlords, but I think we should reserve some control over what is supposed to be rightly separated. Next thing is question of debate, right? Now we are coming to tools, because the manual process is done. Next is automation of the rest of the four things, right? Correctness, performance. How many tools do we need? Do we need just one tool, or do we need a multiple set of tools? And this is also a question of some debate in workplaces, right? Because some developers might want to use only one tool and get it over with, but others will argue, and for some right reasons, that they want to have one tool for static type checking, one tool for formatting, one tool for correctness checking, and all of that. Okay, or is there one tool, right? So that is the dramatics part I did not carry out properly, but we'll come to that answer soon. First of all, correctness. Okay, and this is a term that is probably lost in your first semester algorithms class or third semester, whenever we had it. What is McCabe complexity? Okay, so it is also termed more commonly as cyclomatic complexity, and it's the number of paths the code can take. Okay, simply put, it is like if you have a script where you have control flows, and I don't have to struggle so much. This is a bit of a shredded struggling, because I have code. I will show you code. What the slide is usually actually for is just to show that there's a library called McCabe. Okay, and you can install that, and you can check the cyclomatic complexity through that, which is what I'll show you now. Okay, where is it? Okay, so this is a small script. I'll tell you what this does. All it does is basically it takes in a file, and it looks at the extension, and it tells you whether it's processing a CSV or a JSON based on the input. This is a naive piece of code, and I'll have no qualms in telling you that the input files for both of these are exactly the same. I use the CSV to make a JSON, and I'm going to pass it, just test the extension. Okay, that is all it is. But the main chunk here is that you see flows here, right? If the extension is CSV, it has to do this. Or if the extension is JSON, then it has to do this. Otherwise, it will resort to this. So the cyclomatic complexity here will be 4. Okay, not 3, because if there were no loops at all, the cyclomatic complexity would default to 1. And let me just show you that in execution. This is this. I don't have a very nice interface like Praveen's. Unfortunately, I have to work on that. But this will have to do, and this is how us plebeians do it. Okay, so here the cyclomatic complexity is 3 for this particular file. Okay, that is it. 1, 2, 3. Did I change it? Wait up. Been changing quite a bit. There's a bit of debugging that I'll have to do now. So I'm trying to see why I said 4. Okay, maybe I'm trying to see if I was wrong or if I changed something in the code. So I'm going to try this. And I'm using pass. I was wrong. Okay, 1, 2, 3, 4. Okay, cool. So it would have been 1 if there was nothing, but if, oh yeah, correct. Okay. So imagine if this was not the case. Okay, if this was not the case, then what would the cyclomatic complexity be? It would be 2, right? 1 for normal and 1 more for this. And if this was not there, it would have been 1. And if you have this, it is 1 plus 2, 3, then yeah, correct. Okay. Right. Okay. So that's what it is. So it was not 4 for this. It was 3, and it would have been 1 in the default case. 2 if you have 1 for loop, 1 control flow. 3 if you have. Wait up. There's something wrong in this. Trying to justify the explanation. Will this still be 3? It'll still be 3. Okay. I got it now. So there is no purpose of this. Okay, this does not define the cyclomatic complexity. It is just whatever flow that it has to take that are specialized, that are specified by the programmer. Okay, so that's why that number is changing. I got it now. Yeah. So what is this indicative of? Right, this cyclomatic complexity is an indication of how many tests you need to write, and this ties nicely with what Rohit said about the number of tests you have to write, right? So you have 3 paths that you can take. So you have to write 2-3 tests to actually test out your entire code in its entirety. So that's where McCabe complexity helps. I think I'm missing some charts here. Else is for default case. Yeah. Correct. All right. So next. So we've decided that, now that we have found out our cyclomatic complexity, we need to test. How do we test it? You have different things that you have to do: unit testing, integration testing, and all of that. But the most popular tool is pytest. I did not change it based on Rohit's specification. This is what I said, and thankfully he also said the same. Okay, but also coverage needs to be ensured. You need to make sure that all your paths are covered, so that there are no loopholes or no blind spots where your code can get stuck because of an edge case scenario. So that's why coverage is required, and for this you have libraries like PyCoverage or coverage and all of those things that can be looked up. I'll show you, like, not now actually. Yeah. So next thing is performance. Okay, so how do you test the performance, right? So performance is indicated by 2 things. One is by time, and one is by space. Now space has largely been has largely taken a back seat in day-to-day programming, because you have a lot of disk space to rely on, a lot of RAM to rely on, all of that. But time is still a very, very important thing to consider. Okay, so why you need to consider it is not all operations are equally expensive. Some of them can be optimized, some of them are the most time consuming, and that's why we can use something called a line profiler, and that you can get from the PyPy itself, and you can install it using pip install line profiler. Let me show you that in action. I have a simpler piece of code. Okay, so first thing to do is use kernprof, which also comes bundled with the line profiler library, to actually prepare an L profile file. Okay, one second, let me do it on the right file. This prepares. Okay, I'm asking for n. I'll say n is 100. Okay, so this actually what is this code doing, right? It's just computing the nth Fibonacci number in an iterative fashion. So this is the nth Fibonacci number, and it is ugly by design, okay, because this is what I'll use the linting on later on. But what it's basically doing is just printing out the nth Fibonacci number, and I want the 100th Fibonacci number, which is a huge number. And how much time did it take, and which step did it take the most time on, right? That's where this line profiler will come in handy. Whoops. See, so there is a decorator that is required for the line profiler to actually work. Okay. Yeah. Okay. So if you see, the time that it took the most on is, so it averages out on this particular function, okay, because this is where all the computation is happening. It's hitting it for 100 times. It is iterating over it 100 times, and it is saying that, this is how much time it is taking. And what is this unit? It is 10 to the power of -6, which is microseconds, okay. And this is where the bulk of the time is going. Percentage of time, 25.3%, 24.3%. This is how you read the line profiler. And while it is not a very useful thing to do here, it might be useful in, say, like if you're working with a lot of data and you're trying to do some pandas work on trying to merge some data frames, or you're trying to do an apply function on some data frames. That is where it will come in handy, because you want to know which apply. If you have like a bunch of applies and you want to see which apply is taking the most time, that is where this line profile will be very useful. So I think it should be in any programmer's back pocket just to check it out, right? Yeah, so that's what the line profiler does. But we've already said that space is not a huge concern, but I've seen in PySpark that you need to be very conservative with memory, okay? You need, because when you have data of say 100 million rows or 1 billion rows, and you have like a machine learning algorithm like XGBoost running on it, the memory can suddenly spike from taking the footprint of that data frame from, like, say, for example, if a data frame takes around I don't know, 7,415 megabytes, and you think that's all the amount of space it will take. Okay, it will take 7 GB, and you've allocated around, say, I don't know, 30 GB of executor memory to it. Exec memory is 30 GB. Now you assume that this is fine, okay, but then you do your machine learning work, and suddenly your memory consumption spikes. The process takes around, say, 230 GB of memory. This is not an abstract number. I have seen this happen. That's why I'm not pulling this number out of thin air. And your job will fail. But you wouldn't know that this is how much memory it needs unless you profile it, right? And that is why you use, like, I'm not aware of any, actually I am. Okay, so there is this thing called flopper, wait up, flop, heapy. Okay, I'm trying to remember the name of the function, but these guppy, yes, I got it. Okay, it's called guppy, and this can be used to find out the amount of memory your function takes, but it's a bit hard to set up. Okay, you can just use a simple decorator, and you can get your job done, because the process will tell you how much memory it is taking, and I'll show you that. Yeah, so all you have to do is this is the unit of this is a unit of function that is required to compute how much memory is being consumed at any particular time. Okay, but one thing to keep in mind is you don't want the main memory consumption function running in your main thread, okay, because you don't want that to interfere and be part of the problem, right? So you run it in a background thread, and you try to print out the used memory in each after every, like, 2 seconds or 10 seconds based on your application's runtime. And you can just use it as a decorator, and it will tell you how much memory is required. Maybe you get a bit more creative and try to print the max memory at any stage, so that you don't have to go scavenging through the logs, right? So that is a bit of efficient way of coding you can do. But suffice it to say that these kind of small hacks are enough for you to get what you need in terms of information to carry out your work, which is ultimately allocating the right amount of memory for your executors. So yeah, that's where it really pays to keep track of how much memory is being used. Then finally we come to readability. Okay, I know that many docs have been probably stressing on styling code and pep8 and all of that, but how useful is pep8 really in terms of the bigger picture, right? Okay, now one caveat is, some people might say the bigger picture is for propagation of code, that some people, like when you put your code out there, it's no longer your property. When someone else reads it, they have to be able to understand it. Fair enough. Okay, so I'm not saying it's not important, it's just lower on my set of priorities. Okay, so now which is what this statement is all about. While everyone's tolerances and abilities differ, it's good to have a standard set of practices. So pep8 serves as a good reference. Google has its own styling guide for at least C++. I don't know if it has for Python. But yeah, we have something called pylint and black. I've taken only these two because they are encompassing of all the other styling libraries out there. I'll show you how pylint works first. And now we see that shabby code again, and we can see how we can optimize it further. I'm going to remove this decorator here because we don't need it for pylinting, and it'll throw an obnoxious error. So one slide I wanted to show before this is, see, like our expectation for pylint is that, we'll get a code of say 10 out of 10. Okay, that's what we all think of ourselves. But what is the reality? Minus 6.25. Okay, I did not get this much even in AIEEE. Okay, I did not get negatives there. But now can we do better, right? So what are these different errors? You have different codes here. If you see, you have C, you have W. Actually, you have only two codes here, but the other codes that can be possible are R, E, and F. Okay, R is refactor for good practice, C is convention, which is according to pep8, warning, W, E is error, which is more dangerous, and F is fatal. Okay, I think this is ranked in order of what do you call it? Importance, the most important being the last, and this is the least important. So, and the scoring is also according to that. Okay, so you get minus 6.25 as a sum of all of this, and you've been deducted marks for all this. So let's see if we can remedy this. Okay, what is it saying? Exactly one space required after comma. We have 3 of those. It's on line numbers 8, 17, and 22. We can modify that. Am I looking at the right file? Whoa. Oh, no, this is row and column. Okay, 4 and 5, 8, 17, 22. 4 and 5. It tells you exactly where also. It's so nice. I mean, like, makes you feel so lazy. Yeah, so those are 3 errors corrected. Let's see how much our score improved. It's minus 2.5, still negative, but better than previous, right? We've got a nice improvement. Can we do better? Of course we can. Missing module doc string. Okay, so now this is something that is not to be taken lightly. I feel pylint is doing this injustice because it is bundling it with the rest of the C commands, but doc strings are very important in terms of documentation, and we'll come to that in a bit. So it's saying module docstring is missing. What does that mean? There's module docstring, and there is one more docstring, method docstring. Okay, so if you put a docstring over here, docstring is basically 3 single quotes, a pair of 3 single quotes where you put the purpose of your module or your file. Okay, which is very good for any future programmer who comes along and reads your code. Okay, now it's come down by minus 1.25. Okay, you've got your module docstring. Next, we come to method docstring. What does this method do, right? It returns the nth Fibonacci number. So returns the nth Fibonacci. Now we are at 0, right? That's where we wanted to start. But there's only like we only have to go up from here. Okay, so now all of these obnoxious comments are that it doesn't conform to snake case. So Python wants you to follow snake case, and this is camel case. Okay, a relic of older programming languages that you've fallen into the habit of, that you want to probably remedy in lieu of using PEP 8. So this is snake case. Whoa, a mistake. So be careful when you're like modifying these variables. Don't do what I did just now. Okay. This. So if you see, I have not paid any attention to the error lines, the squiggly lines on the IDE. Okay, it's because I am not in the habit of using these IDEs as much as I should be. So I am still very much reliant on these command lines so far. So now we have come up to 6.25. Okay, that's a huge bump up. Doesn't that feel good? Like, even though it doesn't mean anything. So argument name n doesn't conform to snake case. Like, some of these are obnoxious. Okay, like what can you do here? But it'll give you more points. But okay, so okay. Unused variable var. So now this I'm using just as a stepping into an iterator. Okay, and it is the one thing that I had a problem with this. It says unused variable var, but if I change this to a snake case, supposedly snake case variable, then it'll just consider it. Okay, it'll just say 8.75. I need some clarification on this. Maybe someone here can help me out. And it says final new line missing. Yeah, so let's confirm with that. 10 on 10. Okay, now we have started from the bottom. Now we're here. Okay, so we're on 10 on 10, and it feels good. It looks a bit cleaner. The only thing I'm happy about is this, because later when we run Sphinx, it will give you the documentation. Okay. Yeah, so that is what pylint does. But there is also black. Okay, what is black? Black is an unapologetic black box kind of code formatter. Here pylint tells you what is wrong with your code. Okay, but black will just like format a lot of things that are set by its rules, and it'll just do it ruthlessly. Let's see that. I wish I hadn't done it on the before code. Now I have to. Oh crap. Okay, now let's. You've seen the 10 on 10, right? I got 10 on 10. Okay. Let's see. Okay, this is something that I've not done. I want to see, I'm seeing it just as freshly as you are. We'll do the black formatting, then we'll see how much score pylint gives. Okay, let's pick two, there's some chats, huh? I'm sorry. Terribly sorry. Oh, Google also uses pylint. Nice. Guppy is what I was thinking. Okay. Yeah. YAPF, yes, yet another. For the dummy variable, we can just put underscore. Yes, of course. Okay, so now we're going to do this experiment. Is everyone excited? I am. So wait, first is, we'll check the score, minus 6.25. Wait, minus 2.5. Oh. Why didn't we get lower? What did we do well? Oh, these spacings. No. When we go wrong, we go wrong all the way, man. Okay, minus 6.25. Good. Now we black it up. All done. See, on Ubuntu, this is a WSL. Okay, it's a Windows Subsystem Linux. On Ubuntu or on Mac, you would have got these nice emojis, but here you get these unsupported characters. Let's see now. The code has been formatted a bit. Some of these spaces have been resumed and all of that. Let's see how much score we get. I think it will be 0 or something. minus 1.25. Yes, Lucas Langer fell short of expectations, but it is still better than what we had to do manually, right? So we can just continue and do the rest of the formatting if we want. So that is the thing that Black and Pylint do. Yeah, so pylinting, these are all the different codes that you have to keep track of. Expectation versus reality, it was minus 6.25. Yeah, so now this is for standalone codes. Okay, like you had one script, single scripts, and you could just run these files and you could do it, but it's laborious to do it if you have like a Django project. I'm sorry, Vinay, I know you're rooting for Flask, but I'm going to show it for Django. Okay, so for Django, you have something called Pylint Django, and you can load it as a plugin to Pylint. Okay, so I'll just show you that. I have a Django project that I had written as a sample Django project, and that's what I'll be showing it on. First, let me show you what this sample Django project does for no purpose, because it has no bearing on the quality. How am I doing on time? That is Pylint Flask. Okay, cool. Thanks, Vinay. Yeah, don't rub it in my face. Okay, so where is my browser?
Abhinav Papun has a comment on doc strings.
Who does? Okay.
Hey, so I have a question to ask. So nowadays I'm seeing a lot of people are adopting this type hinting, right? So I am seeing they're writing code like putting all this type hinting part, but they are not putting docstring. So I just want to see, hey, like your point of view on this.
It is not a substitute. It is see, type hinting is a small part of telling the reader what sort of types to expect. Okay, it is not a substitute. So docstrings are still very much useful for telling what the function does, right? It can type hinting can probably tell you what sort of input and output you take in and give out. But then if you want to know the business logic of that function, you still have to use it you have to put it as a docstring as far as like decent coding practices are concerned. Because see, for simple functions like just like a get or a set, you don't need it. Okay, obviously you don't need it. But if you have something that is like, computing the profit and loss of something, or making even more complicated logical changes, you have to tell people what that function does. So docstrings are not one is not a substitute for the other. Both should be used in conjunction, is what I think.
Yeah, thanks for this.
So yeah, so this is a sample Django project, and never pretend to a love which you do not feel, for love is not ours to command. Okay, I did not stage this. This is just like random Alan Watts quotes. But this Django project is what I'm going to format. Or first, I'll show you how much score. Just because it is neat and beautiful is not indicative of a good score, right? Just as no good handwriting is indicative of good content in an exam. So yeah. It's probably the opposite of the point I was trying to make. Okay. I've already, yeah, okay. So if you do this, it'll tell you everything that's wrong with this. Okay, so, oh, not bad. Okay, it is still 8.18 out of 10. And it is saying that, your views file is where most of these problems are. And for all the big talk that I gave about docstrings, it seems like I've missed docstrings in my own project, right? So that is what we'll be trying to change now. And actually, Ani, how am I doing on time? Like, do we have time to change it now?
We are like out of the time, but the next thing is obviously open house. So we have like extra time, so you can take up.
Okay, we'll just quickly do this.
Yeah, cool. Meanwhile, if anybody has any questions, just put it up on the chat, or you can raise hands and Abhiram can talk.
Actually, you know what? We'll assume that I've made all these changes because I have a project where I have made those changes. Okay. So just note all of these changes, right? You have C, and the only new thing is R, okay, refactor, which was not there in the previous one. So what this means is, what it's saying is either all return statements in a function should return expression or none of them should. Okay, so here what has happened in my code is, I'll show you the code. Views. Here I've returned it only for if it is not a post. Okay, so what happens in the other case if it is a get, sorry, if it is a post, which doesn't make sense in this context, but if you have a form and if you have post methods that are going in, how will this code handle it, right? That's what it's trying to ask, and which is a fair question, right? So how I've handled it right now is return none. Okay, it's a very bad way of doing it, but as far as scores go, I'll get a 10 on 10. Okay, so don't do this, like handle all paths properly and be better than me. Yeah, so coming back. So one more useful package is pre-commit. Okay, it's not a package, it's more of a Git hook. And Vinay was asking me about this yesterday, and I already had it in my talk. So let's talk a bit about this. Pre-commit, what it does is, if you have a Git repository and you want to take care of all of these things that we spoke about just now, black and checking YAML and fixing white spaces and some more rules that you want to put, you can set it up as a pre-commit. That's exactly what it's saying, what it's doing. It's doing it before the commit, right? So it's as simple as setting pip install pre-commit install. And then you have a YAML file like this, where you have the default repo for pre-commit. And this is where you specify all your rules. What do you want it to do? You want it to check YAML. You want it to go to black and check black. So these are all predefined in pre-commit, and you can check up what it supports. Okay. Now let's see how it works and what it's expected to do. If I do pre-commit run on all files, it says skipped. There's nothing, no YAMLs to check. Fix end of all files, trim trailing white space, and passed on black. Okay, and how would it have behaved if it was working on a file that was not cleaned up, right? Right. Oh, I'm not set it up for this. Oh, okay. Let's set it up now. It's as simple as this. And I probably don't have the YAML file here. Yes, I don't have the YAML file here. Let's just create one here. And if you see, it is specific to the application, not to the, it's specific to the project, not to the application. I'm moving it, not copying it. Yeah, see here it is failed trimming white space, and here again it's failed black, but it does all of this. So next time I run it, it'll be all passed, right? So that's how that works, and it's pretty neat as far as a Git hook goes. So coming back to our original question of, is there one or many? There isn't just one tool. Okay, there's this thing called Prospector that comes close. Okay, Prospector, how it works is, I think I've run it at least once. Prospector. Yeah, Prospector, you can specify different profiles and all. So if I run Prospector, it says, it does a lot of things. Okay, it runs .g, runs mccab, it runs pepe, it runs profile validator, runs pipeflakes, pylint, all of it. It does all of that, and you can probably add more tools to it as well. Okay, and it says these are the number of profiles. You have not used any profile. Okay, so then I say, okay, man, let's make it stricter. Okay, the profile is very strict. I'm playing with fire here. Okay, but it tells me, it goes very ruthlessly and says, you know, you've not done this, you've not done this, you've not done this. So it increases the level of strictness. And this tool comes close to an all-encompassing tool, but you know, you still have to run pytest and coverage anyway. Okay, so don't scrimp out on tests. Tests are very important. What is on the charts? You can disable a pylint. Yes, you can ignore pylint. Sonar cube is also there. Yes. Sonar cube, I think I have it on my list, but okay, let's come to that. So you have other libraries that you can check. Okay, Bandit is used for finding common security issues. MyPy and Pyre, I was very happy to see MyPy come up in Praveen's talk. It's used for checking type hints. Pyre is something similar. Sphinx is for documentation. It's very important, and you can use it. I have actually not set it up for this project, but I will put it up on the GitHub repo later on. iSort is for sorting all your imports based on category. Like if you have to, if it is like standard library imports, third-party imports, iSort does that. Coverage is for checking your code coverage. vmake is a very contentious tool about, and it says that, you know, it does everything that Prospector does. It's a close competitor to Prospector. It's worth checking out. Deep Source is closer home. It's developed by one of Bangalore's developers, Sanket Saurav, and it's a company here. So you should definitely check it out. And I think I saw a hint of Deep Source in Praveen's library as well. Sonar Cube and Code Climate, I actually had a question. Are they proprietary or not? Because I remember them being proprietary tools. I don't know if they have like free offerings. I've not yet checked them out.
Yeah, they have community, but there are a lot of limitations.
As expected, because community came as an afterthought, I suppose. Yeah, so other resources, you have pre-commit, PyCQA. This is like the big daddy of all quality analysis tools for Python. Okay, Python Code Quality Authority. And here is where you have all the tools that are actually recommended by a bunch of Python communities and like a bunch of people in Python. Yeah, line profilers. This is a GitHub repo we make. There's a talk by James Powell, okay, where he talks very nicely about whether code quality is necessary or not. Because till I saw this talk, I was very single-minded in terms of necessity of code quality, because it seems intuitive, right? That you want to have code quality checks. Yeah, he got me thinking about why it is necessary and when it is necessary, and that's when I tailored my talk accordingly. And there's no harm in considering that. Actually, it's very important to consider that what is important right now. Do you want to ship code? Do you want to make it effective? Do you want to make it perfect? And where do you want to use perfection on? Quality, readability, all of that. So I'll put up the code on GitHub. It's already there as a repo. Yeah, so I'm Abhiram. Thank you. I'm Abhikant on Twitter and Abhiram on GitHub. This repository is there at github.com/abhirama/pyquality. I will put it up on our Bangpypers repo as well, because Vinay's Flask repo is completely there, and I want to add to that and make it a growing list of project talks or talk repos, right? So I'm going to add it to that. So yeah, thank you. That is all. Yeah, so stepping into the co-organizer role for a bit. Now we are getting into our open house section, and I think I've exceeded my limit, my talk time. One of the perks of being the last speaker, right? Don't make this habit. We have 7 minutes for, and 7 minutes plus for any open house topics we want to talk about, like PyTest or an expansion on this. So any questions, please?
So anybody who wants to talk, just feel free to, unmute yourself and start. But if you feel like somebody else is talking, we just stop and continue. We have enough time, we can continue. Right?
Vinay, say something.
Oh, wait. You're talking to me.
Wow, this is a taxi driver moment. No, yeah, I'm talking to you. Say something like
I was
anything
doing
to add to the
something.
conversation.
Can you repeat that?
Anything to add to the conversation?
No, but there is something, by the way, I wanted to add to Bangpypers in general. So
Yeah.
anytime next another person is speaking, I noticed this. I got feedback from my workshop later when people watched the recording. So people were saying that on YouTube you cannot see the Zoom comments. By the way, so if you're replying to any comment, they were asking me to speak it out. So next time
Lovely.
anybody speaks, this is just general feedback.
Oh, excellent, excellent. I will. So I have the chat from last meetup. So I will make that public on your repo, and I'll make this public on our repo as well.
People were asking about that because there were some good questions even here.
Oh yes.
And this thing.
Thank you, thank you. This really helps. Yeah.
Also, the user can share the chart itself, right, while presenting it, so that people can see what questions have been asked real time there. When we are answering.
Well, yeah, that is also there, but a lot of it might also be irrelevant. So that depends. YouTube has this thing where if you comment on YouTube, it'll put it up on the screen. But here, I don't know how Zoom integrates it. By the way,
Zoom doesn't. I think the stream is different.
By the way, you guys, there is something amazing which I found a while ago, which I wanted to tell you guys about. There is this thing called Open Broadcaster software.
Okay.
So what it does is it is open source and it live streams to different sources.
Oh, okay, okay. So Anil was talking about this. He mentioned something called Restream, okay, which does the same thing.
Oh yeah, it integrates that thing. What is that again?
Restream.io. We initially had plans to do that, but I'll take the blame on that. I did not set it up. So we can probably have it on Twitch and all, of course. Like that was the plan. I didn't do it.
Next meetup onwards.
Yeah.
So we have a question from Denim. Denim, would you like to just unmute yourself and ask directly? Or Abhiran, you can take it from the chat itself.
Yeah. So the question is, how do you calculate maintainability in industry environment? So the best thing we can do, the first thing we can do is pytest and coverage. Okay. And also you have CI/CD pipelines that will that you can integrate all of this too, and get reports out of that to see how much of your code is tested and how much of it is still pending. And you can actually basically do all. So you can't run black on all of that. That you'll have to do in terms of development. When you're developing your code as an individual contributor, you'll have to do that on your own systems and then push it. That would be the ideal way. But then once it is pushed and once it is all, one pool of code, what the next thing to do obviously is to test it based on individual units or as an integration, right? So that is how you maintain it, I suppose. Denim, if I have misinterpreted your question, please elaborate.
I can add to this, by the way.
Please.
So one thing I realized is whenever you use pytest, right, make sure your test names are as long as possible. Your test name should actually describe properly what your test is actually testing. Add a docstring even to your tests. Because sometimes if a test fails and you're wondering what you broke, it is always good to find out these things. Like
yes,
you know what feature broke. What did I just break right now?
Absolutely. Sphinx works on docstrings as well. Sorry, docstrings and tests as well. Exactly. But the thing is, when you're, tell me this, when you're running tests as part of a suite, right? And that suite, you can still see individual file errors. Yeah, okay, got it. Yeah, it should be long.
I just add pytest-vvv by default. So I get to see everything.
Okay, good. Hey, Rohit, yes, please go on.
So Rohit, like before you go in, so for everyone, we have a small feedback form that you would like to we would like for you guys to fill up on. So it's just a small Google form. Just take your time and just do that. Please, Rohit, go on.
Yeah, thanks a lot. So I have been reading this book called C Python Internals. It's a really nice book by Anthony Shaw. I'll just I'll put up the links after the demo. But basically, you can modify the grammar of Python and write your own custom code. Okay, and there's also one talk that I'll also link after the demo. So
Yeah. So, did you have a chance to attend the 100th Bangpypers Meetup by any chance?
no, I was elsewhere, but I really wanted to. I think there was a talk about CPython internals, right? I remember.
Yeah. So Anand Chittipodu did a little bit of exactly this. So
Okay.
he called it magic, and then later we figured out what the magic was. And I don't know what the reaction was, but it felt a bit like he had pulled out a second rabbit and shown us it was a second rabbit.
Yeah. I don't know what Vinay is saying. What do you mean by popcorn?
So that book, right? It is insane. If you listen to the Talk Python podcast, Anthony Shaw keeps coming up a bunch of times, and you can actually see him. So you can see his thoughts evolve around that book. What happened is about a year and a half ago, he was asked by Real Python to write a blog post to that about it. So he was just saying. So I'll link this. So on Real Python is amazing, by the way. So this article which I just linked is a very, very long article on the CPython source code. So while he was writing it, he comes back on the Talk Python podcast and he's like, look, man, I wanted to write a blog post. It turned into a textbook. I wrote most of it over here. And then he goes on further that Real Python asked him to publish it as a book. And he wrote more and he spent about 2 years writing this book. He's a code developer, by the way. And this, so Abhiram knows this. I keep complaining that there is a lack of intermediate like resources when you're a beginner, right? You have a lot of resources to learn Python.
True.
You have so much actually, so that it's difficult to choose from. When you come to intermediate level, there are very few, to be honest. And it is a little hard to grow your skills to a high level understanding of Python. So what happens is the only intermediate resources I recommend to most people is James Powell. If you watch his video, he actually talks about adding a switch command into Python. So in one of his talks, he's like, please don't do this, but you can add a switch command to Python. Many people keep asking, this is how you would add it if you had to. So he modifies the CPython source code and shows it. Anthony Shaw's book does not do that, but it actually tells you if you want to become a code developer, this is your how-to guide. It teaches you what is where. So there is this amazing section, by the way. It is about dictionaries. I bought this book when it was announced, and I immediately started reading from the alpha. It is about $25, but I swear to God, it is the best $25 I've ever spent on Python. So if you please buy it if you're willing to read like advanced content. But if not, you can read this article. This article is good enough for most people. So he talks about dictionaries. The way he talks about dictionaries is how early on Guido decided that everything in Python, whatever you see in Python is a dictionary. Even if it is a class, even if it is a list, whatever it is, internally, it is a dictionary. I linked it up there, Sai. It's called Real Python, CPython internals book.
One thing I want to plug here is a Bangalore developer called Prashant. Okay, he also wrote a book on CPython internals. Prashant. Yeah, he was actually a classmate of mine long back. Yeah, and that's why I said it's a plug. So he presented at Bangpypers also, and he actually published it in 2018 December. Okay, and it flew under the radar because of advertising, I suppose. But it is definitely a wonderful compilation, and I think it should be read in conjunction with Anthony Shaw's book.
Wait, I think Anthony Shaw links to this book.
He does?
Wait, because I landed up in some link which says Prashant Raghu's documentation.
Yes.
Yeah. He links to this book.
Lovely.
Let me this thing. I'm linking that also. Nice find. Thank you.
Awesome.
Nice. Good. Credit where credit is due.
So can I go ahead and?
Yeah.
Please.
All right. Just share my screen. Okay, can you see my terminal?
Yeah.
All right. So there's a file called grammar. It sits under the folder directory grammar, and it just this is called the NBF type of specifying the grammar I'm not from a computer science background, so I don't really know exactly how it works. But I know that this is the definition of the Python language, like how it should work, and I mean how it should be written. So what we can do here, the example that I'm about to show is actually is mentioned in that CPython internals book that when I talked about, and that I am also reading at the moment. So what they show is that you can actually, instead of pass, instead of a pass statement, you can say like something else. Let's say for shock value, let's make it Bangpypers or something, right? So if you say Bangpypers, or if you say like proceed, then it will also work like a pass statement.
Nice.
Okay, so I'll just exit it, and there's a make command to regenerate the grammar. So it'll regenerate some C files and stuff, and then you have to again compile the Python source code. So this just means give me 2 threads or something, and then this is don't print anything. Yeah. All right. So now that it's so I'm gonna say take the old parser. Don't take the new parser. I don't know why this is, but that's what's there in the book. You can fill me in later. But yeah. So now if I write, let's say, I hope this works. I'll try with proceed. Okay. Yeah, so it works. So and let's say very weird, but it works. All right, so that's it. That's what I have to say.
Dude, awesome, dude. Can you I know you already sent out the mail for your talk.
Yeah.
Can you just like put this as a snippet and put it in the gist and send it on the same thread?
Yeah, sure.
Nice.
And there's more you can do actually. I'll actually link this this talk by Pablo Salgado. He's a Python core developer. So basically, he shows how you can modify this one, and you can write code like this. Like let's say f was do something like this, and it will map over it. So you can write your own custom syntax, and he writes a dunder arrow method. So basically he hacks the Python this one. So I'll just share that link.
Yeah, I saw something called MacroPy that helps you do something similar.
Yeah, it's pretty cool.
Yeah.
So this is the talk. You can watch it. I'll link that in the email thread. But
yeah, thanks. I mean, Vinay, this comes back to your point of like comments needing to be preserved, right? Right. So all of these have been pasted in the Zoom chats. That if we don't preserve it, it's all gone.
Oh no. So I am by the way. So this is a shameless plug, by the way. I maintain a blog where I keep posting links of whatever I learned that day. So right now, what do you think I'm doing? I'm actually pasting all these links there.
Excellent.
I'll link that, by the way. I'll send that to you.
Cool. I hope you have Google Analytics tied in, because that's going to spike today.
Yeah. Yeah. I have something else.
Okay.
But yes. Thanks, man. By the way, are you speaking somewhere? Rahul.
Rohit.
Rohit. Sorry. Rohit, where are you
speaking somewhere as in I didn't get you.
Icon or in this thing?
Yeah, I plan to propose a proposal.
Send me your CFP. I'm Stone Charioteer everywhere, so just send me CFP.
Sure. Yeah, I'm gonna spend this weekend drafting it. So, and I'm also planning to propose to JupyterCon. That's also there in since it's more Jupyter-oriented talk.
Please do that.
Cool. Any more questions, comments? Just a quick question. Is there a robust plugin for checking local file history? Local file history?
What does it mean? File history? Do you mean command history or file history?
Sorry, my name is Abhijit. Yeah. In the absence of Git or SVN, is there any local file history which is used in PyCharm, which is very good? It is there in VS Code or something like that.
Like local versioning?
Yeah, local versioning of the file.
No,
I don't think so.
not really. If you're speaking as a Windows developer, not really.
Yeah,
It
okay.
overwrites, man. Just overwrites.
Yeah, correct.
Overwrites.
So sometimes if you have not committed the code and if you want to go back to some previous thing, so yeah, that's what.
So VS Code does keep your undos for a while. Don't rely on it. Do not rely
Yeah,
on it. Please commit to Git or Subversion at any point of time, but do not rely on it.
Okay. Thanks a lot. Yeah.
Private repos are free, man. Just like use a Git repo.
Sometimes it becomes, I understand where he's coming from.
Yeah.
Tell Uli I said hi, by the way.
Sure.
So if you're, by the way, if you're using Mac, then it stores like some parts for a bit, but not for long anyway.
Yeah, none of those are reliable.
How does it work, Ani?
So like it stores like some document histories for a bit until you save something like ongoing stuff, and so in the advent of, let's say, your system crashes or something, right, or we just
Time capsule.
yeah, so it will just store that version so when you the next time you restart, it will just take it up from there itself.
Right. Oh yes. That's a good.
Sorry, what was the plugin name? Or I think
That's on a Mac. That's on a Mac.
Mac. Oh, sorry. Okay. Yeah, that's it.
But yeah, always use Git, and that's perfect. So guys, we are like on time, but so we can so we'll be closing the recording now. But we can keep chatting here until you guys are. But yeah, officially we can close this meetup. So this is an open discussion house now.
Yeah, and thank you all so much. Thanks to all the speakers. You made time on Saturday, and thanks to all the attendees. Right? You all made time to stick around. So I hope you derived something out of this, right?
Yes, and for everyone, if you are still there and have not filled up the feedback form, please do so. It will help us plan better the next time.
Hey, Aniruddha, you mentioned there were some questions for my talk, but I scrolled up and I couldn't find any questions. Is there something missing?
Yeah, even now there's like too much to scroll. Is there anybody who has more questions for Praveen here? Praveen is still here, so you can just directly ask him.
Classes. I mean, how we can implement it. I mean, that implements will work. How to apply that.
Vinesh, can you start from the beginning, your question?
No, with help of type, we can have a dynamic class creations, right? But this implements whatever we see in Python 3.6, whatever I explained, how to apply that. That is my question.
Could you be more specific on what you mean by dynamic type?
For example, there is a parent and child classes. I'm not directly inheriting the child class.
Okay.
I'm just doing with a type. So on the fly, it's getting inherited. So how this implement will work in that case?
I'm sorry, I didn't get your question exactly on the derived class. What exactly is it deriving? It's deriving from the parent class, right? But what exactly are you doing differently in the child?
No, I'm having like several child classes, okay?
Right.
And there is one parent classes, okay?
Right.
So I'm not just mentioning this is the parent class directly, okay? With the help of the type, we have a type of, right? With help of that, I'm doing that. So dynamically, I'm defining this is the child and this is the parent.
You are using the type to dynamically create child classes using type, right?
Yeah.
So you're giving the name of the class and defining its base classes and using the dict to say what are the
Because in one of the project I have seen for some use case they have used like that. I'm just curious how to have this implements, how it works.
You can still do it. So you can say implements of the class that you have created. Right? Can I just type it on chat if it is okay? Or
yeah, that will help. Yeah.
Maybe I'll share the screen. Let me Just give me one second.
Sure.
Let me know if you're able to see the screen.
Yeah, I can see.
Right. So what you're saying is my class. Let me put it in the middle. Right. So you're saying is equal to type of this way, right?
Yeah.
This is what you're doing, right? So you can also do my class. I mean, basically you're redefining it, or you can say whatever some is equal to implements of right. This is the equivalent of doing decoration.
Decorator. Okay.
Right. So if you have a func and this is almost the same as decorator of, right? So you can use it like this and decorate the class. All you have to do is decorate your class however you created it with the implement this thing. So this will basically have this. There'll be two of these, right? I can probably give this a try and get back to you on this. But this is how you would do it.
Sure. Yeah. Thanks.
For everyone, so I'm also sharing some Bangpypers links. This is the Bangpypers blog. You can read up on the past meetups and so on. We also have a Slack channel where you can join and interact with the community. So somebody I think asked where you can work with other Python stars from Bangalore and so on. So you can just do that. So yeah.
Also, if you have any doubts regarding Python that you're just brainstorming and you want to ask the community at large, if you tweet at Bangpypers, we will RT it and you'll get an answer, or we can just discuss in the broader forum. Or if you have a section, if you have a question that you want to ask the mailing list, that's also there. So there is a community to be made, to be taken advantage of in terms of doubt clarification. So let's use it.
Absolutely.
By the way, one last thing. I just wanted to ask something. How many of you guys are reading PEPs? PEPs.
Only recently, man.
Yeah, even I started very recently. So I would recommend a lot of people who are reaching like the intermediate to advanced level. What you should. So Python has this way of, if you want to change something in Python, if you want to say, hey Python, give me a switch statement, all you have to do is write a very detailed enhancement proposal, post it on python.org, and then people will take it for consideration. By the way, for 3.9 or 3.1.0, not for 3.9, for 1.0, they are considering something like a switch statement. Not exactly like a switch statement, but they're actually considering what is that thing called in Haskell, where depending on not function overloading, but you have those kind of pattern matching for functions. It is called something. I'll post the link later. I'll tweet the link at Bangpypers later.
Overloading?
No, not exactly overloading. So they're doing some kind of pattern matching for functions, but not exactly for functions, but for lambdas. So they've been trying to implement this for a very long time. So if you do this, if it gets implemented without anybody fighting or without anybody quitting their jobs, what will happen is you'll have a statement which allows you to do something very advanced, like if this condition do this, however, it builds on the walrus operator. So it's a very technical read. I will send the link out later. I'll tweet it at Bangpypers Twitter, so you can forward it out to people.
Cool. Is it like glob for functions?
Exactly. It's glob for statements rather than staying for functions. It's a glob for statements. And it has been rejected and reproposed for the last 15 years.
Wow.
The first time it was proposed, Guido himself proposed it. But nobody could get a consensus on how to do this. The keyword that would be coming would be match. You would have a match keyword, not the function. You would have not the method. You would have a match keyword, and with the match keyword, it will be like, if this scenario, if this regular expression kind of situation evaluates, do this, do that. So it would be very similar to having a switch statement in Python.
Yeah, link us to the PEP, man. I think it's
I will link you to the PEP. I'll link you to the PEP. I have to find it.
Yeah, Ani, Sai is asking, is there an invite to the Slack group? Yeah, that
So
is.
I think there is an auto invite thing. So if you open it and just enter, you should be getting an email directly. Just try it out. If it doesn't work, you can always reach out to us.
Cool. Okay, then I think we'll wrap up. We'll post all the links that are relevant on the blog post, on Twitter, on Meetup, and all of those. Again, thank you all so much. I can't stress it enough. Like on a Saturday, man, who makes time, right? So thank you so much. Yeah. See you.
All right. See you all. Thanks.
Thanks.
Guys, bye.